And since then, Space India has been working for more
Guest
than two
यहाँ से
decades in
guest will move
developing
from there.
astronomy, space science, and STEM education, including experiences at grassroots levels
Guest
and
कहाँ से
beyond.
सूर्य
The
guest
Space
कहाँ से
Group of
लेंगे
companies
guest
combines
यहाँ से
education, experiences, and
माइक लगा
innovation,
दूंगा
aiming to revolutionize the education and tourism sectors by making astronomy and space science accessible to all. Our mission is to impart scientific temperament globally and have already inspired over 1.5 million students and engaged with more than 1,000 schools in India for astronomy and space science based curriculum and workshops.
Space India. And I feel grateful to share this information with you all that it was featured in prestigious astronomy picture of the day released by NASA. Now I request all the esteemed guests to please illuminate this momentous occasion and symbolize the light of knowledge and wisdom by lighting the lamp. Thank you so much, everyone. The lamp has been lighted. I request Vice Principal Ma'am, Ms. Sonia Chavra, to please stay back and share a few words with all of us. We welcome Ma'am with a huge round of applause. Good morning, everyone. Teachers and my dear students, a very warm and enthusiastic welcome to each one of you from the Balbharti Parivar. Today is a day of exploration and inspiration as we gather here for an event that delves into the fascinating realms of space exploration. We are truly honored to have a distinguished personality in our midst. Please join me in extending a hearty welcome to our esteemed chief guest for the occasion, Shri N. Raghunathi Ji, Deputy Director, DTDI. Thank you so much for being here with us this morning. You must have heard a lot about him. Thank you, sir, for being an integral part of EduOdyssey, Chandrayaan 3 and beyond. Your presence adds a stellar dimension to this event, and we eagerly look forward to your address. Once again, a warm and enthusiastic welcome to Shri N. Raghunathi Ji. On behalf of the school, I also welcome Mr. Shivam Gupta, CEO and MD, Space India, and Dr. Sachin Bhamba, CMD, Space India. The sky is no longer the limit for our pride. Words of our Honorable Prime Minister Modi ji to the ISRO scientists. ISRO, the Indian Space Research Organization, has indeed made significant contributions to space explorations, and its missions like Chandrayaan have garnered attention and admiration around the world. The remarkable achievements of ISRO bring us great pride, and their ongoing dedication to space exploration serves as a global source of inspiration for all of us here. It is with great pleasure and a deep sense of pride that we extend our heartfelt gratitude to Space India for orchestrating this absolutely remarkable event today. Today's gathering represents a convergence of curiosity, education, and the boundless possibilities that the field of space offers to us. We would also like to acknowledge the special connection that Balbharti Public School, Pitampura, shares with Space India. Our partnership has been a source of inspiration for our students, parents, fostering a deep sense of learning and exploration. Through initiatives like this event, we continue to sow the seeds of knowledge and spark the flame of curiosity in the young minds that walk our corridors. As we engage in discussions and experiences that await us today in this event, let us remember the powerful impact that organizations like Space India have in shaping our educational landscape. Here I would want everyone to clap for Space India. Our gratitude extends not only for today's event, but for the ongoing commitment to ignite the flame of curiosity in the hearts of students. In fact, I've just been sharing with Sir that our children are so excited to visit ISRO. And it will be wonderful if Space India is going to take our children and teachers to visit ISRO. And that's soon going to happen. Once again, on behalf of the Balbharti Public School, Pitampura, a sincere thank you to Space India for making this event a reality and for strengthening the foundation of learning in our students' lives. Today, my sole message to the students would be, dream for the stars, do not settle for anything less. Seize the opportunity to learn, to be part of a mission that reaches for the stars, and always nurture a belief that anything is possible when you dare to dream. Give your wings the flight, your soul the fuel, and your brain the curiosity to lead your way through life. That is a life well lived. Thank you, everyone. Have a wonderful day.
Thank you so much, ma'am. Moving forward, now I would like to call Mr. Vikrant Naran, who is currently the Chief Technical Officer in Space India. Vikrant sir has been a part of Space India for more than 15 years now, and today he is going to talk about the pride of nation, ISRO. So with a huge round of applause, please welcome Mr. Vikrant Naran on the stage.
Thank you, everyone. So very good morning to all of you. Great. I want more energy. Good morning, everyone. So my name is Vikrant. I'm coming from space. Well, I'm coming from organization space, which you just got to know about. And I'm very excited. Are you all excited? Yes. Okay. So I hope today you will enjoy a wonderful day. And so today I'll be talking to you about, so this is very exciting time. You are all excited about Chandrayaan? Yes, so you can see we've got Chandrayaan right here. What is the name of the lander, do you know? The lander. Pragyan is the rover. Vikram. So today I will be talking about Dr. Vikram Sarabhai a little bit, and I will be introducing to you. I am going to give a short talk on the topic ISRO, pride of the nation. So first, I am going to start with a quote by Carl Sagan. The size and age of cosmos are beyond ordinary human understanding. Lost somewhere between immensity and eternity is our tiny planet. Home. It's our tiny planetary home. In a cosmic perspective, most human concerns seem insignificant, even petty. And yet our species is young and curious and brave and shows much promise. In the last few millennia, we have made the most astonishing and unexpected discoveries about our cosmos. They remind us that humans have evolved to wonder, and that understanding is a joy. That knowledge is prerequisite to survival. So that means space exploration is not an option, it's a compulsory thing. Space exploration helps us find, we can look at our planet from space. So many planets are there in the universe, but Earth is one of them, but Earth is the most special one because we live on the Earth. And you are all special because you will not find another one of you in the entire cosmos. So just touch yourself. You are made up of star stuff. You are Tare Zameen Par. So here Carl Sagan says, I believe our future depends on how well we know this cosmos in which we float like a mote of dust in the morning sky. So space exploration is important. Someone like so many people in India are hungry. Okay, and you can say that if we spend on feeding the people, then probably that will be a better expense. But that's like saying, should you build hospitals or should you build schools? Both are important. So ISRO is fulfilling a wonderful role of being a space agency of India. Here we are looking at the bullock cart in which a satellite was transported. There is a photo of a remote sensing. That means we are looking at the Earth from the top. Space exploration is important because that's the only way we can look at our planet as a whole. We can get to know what is the geology of India. And there is a father of our space program, Dr. Vikram Sarabhai. Next slide, please. Here is a beautiful picture. We are proud of this picture, which made it to astronomy picture of the day, taken by our team members in. This is the launch of Chandrayaan 3, and it was taken by our team members at Chennai. Next slide, please. So India is one of the first space, it was I think the fifth or sixth space agency to form in the world. It formed in 1962. Before that, USA, Russia, in 61 there was Pakistan formed their own space agency. There was European Space Agency and France, and then it was India. And you can see here, India is one of the countries. There are 80 space agencies right now in the world, nearly 80, and India is at India had its own rocket program. That means India made its own rocket in which can take us to orbit in 1980. We were 1, 2, 3, 4, 5, 6, 7 in this. So there are only currently about 13 space agencies which can send a rocket to space, and we are proud that India is one of them. So whenever we talk about like event like Chandrayaan, we all feel a sense of pride. That's what space exploration does. We all feel hopeful, don't we? Aren't we all feeling that pride and optimism because of ISRO? Yes. So this is what space agency does. When we do science, every person on this planet is impacted. You can see, what everyone is talking about Chandrayaan right now. It's a historic moment for us. Next slide, please. And India is one of the top space agency in terms of its spending also. You can see right now it's at 8th number in terms of spending. This is from last year. The budget. How much is United States spending? And you can see India is there at 8th number. It's almost very less of the United States, but still we are the agency which is one of the topmost agency. Next slide. And now the next wave of space exploration is coming. That means new startups are coming. There are at least 140 startups got registered in India and which are serving the entire world now. Next slide, please. So I want to talk about how Indian space program started very briefly. So you all know Vikram Sarabhai, who was the father of Indian space program, and he was helped by two very important people. One is Dr. Homi Bhabha and one is Dr. Jawaharlal Nehru. Dr. Jawaharlal Nehru, this is then India made its own satellite. So first, India used someone else's satellite. Then India made its own satellite, Aryabhat. And this was launched in 1975 itself, indigenously made. So how can India do this? How can India do this wonderful thing which other countries could not do because of the leadership of these people and because India reversed the timeline? We leapfrog. इसका मतलब है कि सपोज एक कंट्री के अंदर एक कंट्री ने अपनी टेक्नोलॉजी को एडवांस करना है तो वो क्या करेगा अगर नेटवर्क अगर लोगों को कम्युनिकेट करेगा वन इज कि यूज द लेटेस्ट टेक्नोलॉजी दैट मींस दैट सेल फोन्स है so you don't need to lay the ground infrastructure of cable phones which used to come first. So what India did under Dr. Vikram Sarabhai's vision is India laid a foundation by reversing the timeline. Other countries did rockets first, missiles first, then rockets, then satellites, then they came to application. India did reverse. So India has set a model for any other country to follow. It just went with social national development goal and nothing else. Next slide. Here is one of the first. This is this foundation for this rocket launch, which made India a first space-faring nation with its own rocket technology, was also laid by Dr. Vikram Sarabhai before he died. And this was launched in 1979, which failed. 10,000 people worked on it. But in 1980, the first SLV-3 launch of India was successful. Next slide, please. It led to today's rocket technology. So I would like to stop here with this. India is ready to soar and we are at Chandrayaan already. How many of you would like to become astronauts next? Wonderful. Thank you. So I would end my talk here. Thank you very much.
Thank you so much, Mr. Vikrant, for this wonderful and informative presentation. He always comes up with something new. So now it's time to listen to the incredible journey and success of Chandrayaan-3 from our chief guest, Mr. N. Raghu Mite. I invite Mr. N. Raghu Mite to the stage. Please join us in welcoming him with a huge round of applause. And I would also like to invite Ms. Avni Patra to come on the stage and present a telescope to Mr. N. Raghu Mite. Please now. telescope by Space Arcade India as a token of appreciation for Mr. N. Raghupati.
Good morning, everyone. Good morning, sir. Yeah. Before I begin the talk, I take an opportunity to thank today's organizers, the Space India, as well as the Balabharati Public School, Pitampura. To them, the respected dignitaries, Dr. Sachin Mamba sir, and Dr. Shivam Gupta, and Madam Sonia Chabra, and Madam Avani Patwa, and Madam Anjali Verma, and Principal Madam Menu Vasami, and respected Vikram Naran. So with this, actually, I would like to begin the talk. And last but not the least, I also want to thank the audience, the research community, as well as the gems of today's actually nation's students community who come here, actually who gathered here to actually have these interactive sessions. I have this. Okay. So can I start? Yeah. Okay. We'll start with the day. So today is actually, I understand that today mostly we'll be talking about Chandrayaan 3 as well as beyond Chandrayaan 3. And I'm very excited to see the Chandrayaan module. We have a module here, the Vikram lander as well as the rover Pragyan. So I did not expect this. So I really actually am thankful to the organizers. And today's talk, basically, I will be covering the science and career in space, because what is important is the career. So ultimately, what we do science is for the career only, because you all becomes is actually Vikram also asks you, many of you wanted to be an astronaut. So that is your profession, is your career. So we are knowing how to go, where to go, because we will not be going, we will not be, science will not lead to anywhere. So in that aspect, actually, I have included the career also. So next slide, please. So outline of today's talks, so we'll actually start briefly about the universe, because where we live in, then our solar systems, then our moon, then we will come to the mission Chandrayaan, and we also will come to the mission Aditya, mission to the sun, as well as the mission Gaganyaan, that is our human spaceflight mission, as well as the Caribbean space mission. So briefly, actually, yeah, next slide please. So you know the universe where we are actually living today. It all started with a small dot, that is called Big Bang singularity. It was very small. It was a tiny dot which was infinitesimally small, and it was too hot and too dense. Because today, what we everybody today we are actually all the planets everything was contained in this small dot, that is called Big Bang singularity. So can you believe that? We never believe, because you see the seed of the pipal tree, it was very small, but when it's grown, how big is the pipal tree? The mango tree you have seen, but the seed was very small. Like that, this was the seed of the universe called the Big Bang singularity. You remember this point, Big Bang singularity? So everything began with this point. Okay, so next slide. So this is how we began, Big Bang. That means the universe began with the Big Bang and space-time was born. There was no time at that time, there was no space at that time. The definition of time came from that moment. Okay, so when was the actually Big Bang happened? So next slide please. So if you see the Big Bang, so we can actually assume that this is the balloon model for students. You see the balloon when you inflate, actually by pushing the air inside, what is happening is it becomes bigger. If you push air more, it becomes bigger and bigger. So you see the dots in the, do you have the okay. So if you see here actually below, there is one small n, okay. The small n becomes bigger. Now the balloon is becoming bigger and bigger. 2 centimeter, it becomes now the distance between 2 centimeter and 1, it becomes 4 centimeter. So like distance between the 2 points become actually bigger and bigger. So that means that universe is expanding. Okay. So universe is expanding since the Big Bang. Next slide. And how old the universe, you know? our universe, since the Big Bang, it is around approximately 13.8 billion years, that means 14 billion years old. So the universe where we are staying, everything is actually 14.8 billion years before it was formed. And today the solar system is 4.5 billion years. The solar system was formed much after that. Okay? And the past galaxy formed actually around 1 billion years. And today, at the end of the day, this actually the solar system was formed 9 billion years. After the Big Bang, that is 4.5 billion years from now. Okay? So next slide. So in astronomy and all those things, you may be knowing because today's scale, see the distance between you and me, I cannot measure in kilometers because kilometer is very big. So distance between you and me will be measured in meters or centimeters. But in astronomy, the scale is for the light year because light is the distance traveled by light in 1 year. So it is actually the light travels how fast you know. The light travels whenever I did a line there, the light travels 3 lakh kilometers per second. Light travels so fast. This is the fastest speed achieved by anything, okay, in the world. The speed of light is the fastest. So what happens is when you lit a candle, you cannot. I lit a candle in Bangalore. Can you see in Delhi? No, you cannot see because of the atmosphere. Otherwise, if there is no atmosphere, we will be able to see them. It will take some time, but how will you be able to see that? Okay. Today, when you lit a bulb in Delhi, I cannot see in Bangalore because of the atmosphere. Okay. So. See, 1 light year distance, how much you see? 9 trillion kilometers. How many zeros are there? After 9 zeros are there. It's too big, it's huge. Okay, so next slide. And universe, the total universe is almost infinite. But how the observable universe, that is, to what extent we can observe due to limitation of today's technology. Because this actually the radius or the horizon of the universe is ever expanding. So today I can measure up to 94 billion years diameter. So when I'm standing here, I'm the center of the universe. When you are standing there, you are the center of the universe. So you can see actually total radius of 47 billion years. This is very huge. But the entire universe is almost infinite. And actually next year it will be much bigger because we will be having more powerful telescope. Today, because of limitations, I have been able to observe only 94 billion years. Okay, next. And our local universe, where our Milky Way galaxy is there, this is called the local universe. So if you compare with the universe, total universe, see, local universe is size, you see, it is only 24.6 billion trillion kilometers, but observable universe is 80 billion trillion kilometers. So if you compare in the percentage, because it is always easy to remember in percentage wise. So local universe, what we observe is less than 3% of the observable universe. It is very, very small. What we observe today or what we did today is only 3% of observable universe. Okay? Next. You see, space is 13.8 billion years, but the size is 94 billion years. Is it contradictory? Because the size is bigger than the age, like actually the sun is older than the father. Is it possible? No. Correct. But what happens is this is a little bit tricky here. See, you see the axis. The x-axis is the age of the universe, y-axis is the size of the universe. So when you see the actually axis side of coordinate, what is happening is from the Big Bang timeline, the universe is expanding. The rate of expansion is not constant. Okay. So what happens is as time goes on, the universe expands. Initially, it's called inflation. Inflation is a very important point because after the Big Bang, at a very instantaneous moment, the universe expands like anything. Okay. Actually, people believe that even at this point, actually, it is the particles were at that time there was no galaxy. The particles of formations, including atom formations, and your hydrogen was lost from. We can also told that years quoted about the scientists. Okay, so first actually the atom form was the hydrogen. After the fusion, so helium come, and then your lithium and all beryllium all these come. Okay, the parts is hydrogen. So in order to form hydrogen, what you need? One proton and one electron. So these proton and electrons, this formation happened in during this time because it was very cold. So during these inflations, they were traveling even much faster than the velocity of light. They believe that. So the universe expands like anything. Next. So this one age is 13.8, but the size is 94 billion light years. So this can be explained by a law called Hubble's law. Hubble's law says that The galaxies, whatever we observe today, they are actually expanding like anything. But what is the rate of expansion and how do they expand? He said that the farther the galaxies, faster the velocity. Because once start moving away, they will start expanding rapidly. So actually the galaxy today we observe today and we observe from farther because whatever the wavelength that is called redshift. Redshift means that the wavelength, you know the wavelength because other students may be knowing the distance between the actually trace to trace or the truck to truck. Okay, in the transversal way. Or otherwise in the longitudinal way, you know between actually the real fractions and compressions. So distance between your trace to trace is stressed like that. Okay, so the redshift means that your wavelength is stressed. Blueshift means you are compressed, your wavelength is compressed. So the light emitted by the distant galaxies are stressed like anything because they are moving farther at a speed much faster. Next slide. So let us see how many galaxies are there, how many stars. Our Milky Way galaxy is having approximately 100 billion stars. Okay, so this is the number. Now, again, we have 2 trillion galaxies. This is the maximum galaxies in internet. You may be actually various number. This is the maximum galaxy. I have assumed that 2 trillion galaxies is the maximum. Actually, some numbers are there, 2 billion galaxies and all those things, but this 2 trillion is the maximum. So, assuming that 2 trillion galaxies, that means how many zeros are there? Again, 2 after 9 zeros. Okay, then if you assume that Milky Way galaxy is 100 billion stars, multiply this, we have 2 into 10 to the power 23. 23 zeros after 2. We cannot count at all. You know the Avogadro number is almost the same. Correct? So that many atoms, that many molecules, that many stars are there in the universe. Okay? So this is quite interesting. So we are not alone. That is what we can call. So like us, but we are unique. Next. So if you see the Milky Way galaxy, I told you the universe began with a small dot, and our Milky Way galaxy is another dot. If we compare to other galaxies, our nearest rival is Andromeda galaxy. Okay, and the next is M87 is little bigger, and the biggest one is today what we know is IC 1101, which is 60 times bigger than today's our galaxy. This is Zion galaxy. So if you see the galaxy, the scale. Our galaxy is another dot in the universe. And the Milky Way and Andromeda, our nearest rival galaxy, they are separated by 2.5 billion light years separations. It is very, very far. We cannot travel during our lifetime. Okay. And it is actually, astronomers are telling that our galaxy and Andromeda galaxies, they are coming closer, they will colliding, we don't know. Okay. So the physics of the universe is difficult to understand. Next. Again, coming to the Milky Way is how big again? This is actually, see, Milky Way is a spiral galaxy. Right side, you also have put in Space India logo, it is a spiral galaxy. Okay, Milky Way is a spiral galaxy, it has many arms, and 1 lakh light years. This is the length, and we are at the center. The sun is at one of the 2/3 of the from the center. It is at a 2/3. Okay, not at the center, not at one and 2/3. So we are here, and the width is 1,000 light years. Next, this is the location where we are. Our planet Earth. It is here in one of the arms. Okay, so we are not at the center. We are not. There is an advantage of this being at the edge because we are able to photograph. If you are inside a building, can you photograph the building? No. If you are at one of the arms, you can at least photograph the building. So this is the advantage of where we are. Since we are at one of the arms, we are able to photograph and know the shape of this galaxy. This is the advantage of where we are. Okay? The next slide, please. Yeah. Coming to the solar systems, you know, the Earth, because you know solar systems, the family of sun and other planets, planetary systems. We have 8 planets today. Pluto is no longer a planet, it is becoming a dwarf star. And Earth is a Goldilocks zone. You are aware of this term Goldilocks zone? Yes, because it means that it is habitable. Because for every actually the star, we are in a particular distance at which actually the liquid, because this water can be found in three phases, liquid, gas, and the solid. So this water can be found in the liquid form. So that is called the Goldilocks zone. So we are at the right point. Because of that, only water is available in liquid form. We are able to survive. Moon is also almost at the same point only, but liquid water is not available. Okay, so therefore, otherwise, other actually gases and the molecular waters are available on the moon also, but liquid water is not available. Next. So you see here the size, and the Voyager, the Voyager aircraft from USA, NASA, they have crossed almost actually the birth of these solar systems. So it has crossed up to this heliopause. Heliopause means the influence of the solar wind is almost negligible at that point. Pause means stop. When you play a video, pause means it is stop. No, the influence of the sun is almost negligible there. Because the space weather is almost negligible. Therefore, this is a heliopause. It is up to that point. So if you see the nearest star, the Alpha Centauri, Proxima Centauri, so it is much beyond the Oort cloud. And you know that the radius of the solar systems, we are here next, like next, yeah. Okay. Yeah, I think that slide comes later. So the planets, moons, our solar system has a lot of planets. We have only one actually the moon, that is, we have only one moon called Chandra in our actually Sanskrit. So, but see, total together 284 moons are there, and Saturn is having maximum number of moons, 145 moons. This is also as on today's 2020-23. Next slide, please. See, number of moons also keeps increasing. As I told you that because of technology limitations. See, in 2022, Saturn was having only 62 moons, and in 2020 and in 2022 it was having 80 moons, and today it is more again. And next year again, who knows that they will be again discovering more number of moons. But only our one moon is unique. Okay, next slide. This is what I was looking for. This is actually, you see, you assume that this is actually a circle of various radius. So the sun is here, Oort cloud, and we are actually our solar system is within 1.5 light years radius. So all other things are beyond that. Alpha Centauri is coming the 4 actual light years radius, and other more stars are beyond that. Next slide. Yeah, this is a very hypothetical question, but it is interesting to you. Can we see our own birth? Today I am 47 years old. Okay, so when I was born 47 years before, I could not see, because therefore in English I always tell, we always say that I was born. We can never say that I born. Okay, I was born. So when we were born, whether we can see our own birth. So this is very interesting question, because the thing is, you see me, I see you, because the light comes from you and light goes from me. So when light comes from you, it falls on my eyes and I'm able to see you. When I turn this sensor to other side, I'm able to see you. That means light is coming. Light is actually coming everywhere. Only thing is I should look at you, then only I'm able to see you. Correct? That means light carries information, irrespective whether you are looking at or not. Correct? No? So therefore, when I was born, the light carries my information to the space. Correct? So what we see today is basically the past. You assume that the moon is in approximately 1.3 light seconds. Means light takes only 1.3 seconds to travel from moon to earth. And from sun, it is around 500 seconds. Now our nearest star is the Proxima Centauri, which is 4.2 light years. Let us assume that one child is born somewhere in the Proxima Centauri, in another exoplanet. Then it is brought to the earth. Then after 4.2 years, light will come to the earth. So when the child becomes 4.2 years old, you are able to see his own birth. So, okay. So this is very interesting, but it is hypothetical. So next slide. Likewise, Mahabharata Ramayana, Mahabharata is considered to have happened 7,000 years before the birth of Christ. And Mahabharata, Ramayana is 7,000 and Mahabharata is 5,000 BC. So more than the speed of light, you will be able to guess somewhere. Okay. Next slide. So now coming to the Earth moon systems, you know the distance of the Earth, distance of the moon from Earth is 384,000 kilometers. So this number we should remember that because it is very important number, and the distance between Sun and Earth is 150 million kilometers. This we call it one astronomical unit. Okay, this also number also we should remember. And this number, this diagram, you see, the perigee, epigee, perihelion, epiron, these are important terms we should remember because see, perigee means, you know, nearest point to the Earth. Because when you say the Chandrayaan, 100 by 100 kilometers, so what do you mean by that? That means one is a perigee, one is apogee. When we say, because perigee and apogee are same, when we say 200 by 300 kilometers, larger number is called the perigee, smaller number is called the larger number is called the apogee, smaller number is called the perigee. But this same nomenclature is used differently for other systems. For Earth is only called perigee and apogee. For other is called the perihelion and ephelion. Okay, if you see for other sun or other planets, the term will be different, but the meaning is okay. So see how big is the Earth? 4 moons can fit to the Earth, and the distance between moon and Earth 30. Actually, Earth can fit. Okay, next slide. This is another golden ratio. Have you heard about this golden ratio? Yes, this is another interesting number. You should actually, I want you to explore because this is a very interesting number, and people started exploring more about this number in all branches of science and every actually fields of even economics. Okay, and what is that in arts and business, finance, everything. So the golden ratio says that this was first defined by Euclid. You know that Euclid geometry. So Euclid, he told that we have to divide a line in a ratio between A and B in such way that A plus B means whole is divided by B, A. Okay, the whole is divided by the longer is equal to longer divided by the smaller. This number is always constant. We call it 5, which is equal to 1 plus root 5 by 2, which comes approximately 1.618. It is an irrational number. It's not exactly not equal to. It is an irrational number. But this ratio is very interesting that it is believed that almost the universe was designed with this number as a tool. Okay, because everywhere this number pops up. And this is related to the Fibonacci series. Fibonacci series is very important. You see the petal of the flower, it may be either 3 or 5. Most of the flower petals. Okay, so that means this Fibonacci says that 0, 1, 1, 2, 2 means the next number will be the sum of the previous 2 terms. Okay, so that means you see here the third is the 0 plus 1 and the fourth is 1 plus 1. So like that only it proceeds. It's a very simple number, but it is reflected everywhere. And this golden ratio and the Fibonacci, they are related. The ratio of the 2 Fibonacci numbers, okay, is approximately equal to the golden ratio. The larger the series, the ratio is closer and closer to the golden ratio. So it is very interesting. How is it interesting? If you see actually the moon and Earth system, you see here, if you put a moon, the sum of the distance between these 2 radius, we can fit to one triangle. This triangle is called Kepler triangle. It's very interesting. In the right angle triangle, and actually hypotenuse is the golden ratio, and the other 2 sides 1 and root 5. And moreover, the distances of these planets in the solar system, if you normalize the distance of this Mercury, is almost standing to the golden ratio proportions. It is very interesting number, so you please explore more in this number. Next slide. Now coming to the human anatomy. So can you say that, how can you say that a person is beautiful? Okay, because there should be one rule which says that if this is satisfied, then it is beautiful. Okay, the person who is very tall also cannot be, we cannot say it is beautiful. The person whose hair is very long also cannot be beautiful. The person who is very short also cannot be beautiful. So like that only there is a golden ratio that the distance between navel to the toe, distance between the head, navel and head, there should be a certain proportions. Even it is in the hands, toes, and in a DNA, even in the teeth. Because we know the front teeth are bigger, but how big the teeth should be? If it is very big, it should be beautiful, correct? So there should be in some ratio. So you please explore more on this number. Yeah, next. So now coming to the moon, because we are closer to the Chandrayaan 3 now. Moon, you know, in mythology it was considered as a god. Okay, because all the planets we are considered as God. If you see in any temple, if you go, Navagraha will be there, generally we pray there. So all these, whatever we know, the planets, at that time what happened is only these were known because there was no telescope. Whatever they can see through their eyes, only these are actually the planets. So they call it the planets because at that time the knowledge was not that much that what is the definition of a planet, whether they revolve around the sun or where they don't know. So therefore they call it as all as planets, even the moon also. So therefore moon was considered as a god. Next. The origin of the moon, you see how the moon was formed. I told you that the moon and the solar system was formed 4.5 billion years ago. So there are actually four theories are there. One is capsule theory. Capsule theory means that moon was formed independently, and it actually so happened that it was coming closer, like we are launching Chandrayaan 3 now to the moon. So Chandrayaan 3 is captured by the gravitation pull of the moon. So like that only. So Earth captures the moon. Moon was coming from somewhere in the universe, and it was entering the Earth's gravitational field of the Earth, and after that it was captured. So that is for capture theory. And the fission theory means that when the Earth was formed, and some part of the Earth was actually flung away, then actually slowly with the gravitational pull collapsed and then moon was formed. And another was formed actually co-formation theory. Co-formation means moon was also formed together, Earth was also formed simultaneously, all formed together. Okay. Another is called most accepted theory is called giant impact theory. Giant impact theory says that when the Earth was not properly formed, that is called the proto-Earth. So one planet called Theia, this was the size of the Mars. So it was coming and hitting the proto-Earth. Then after that, because of the heat, the impact, actually some amounts of that one actually flung away. Then after that, slowly the bullets are formed, and actually these small bullets again collapsed together because of the gravitational pull, and only one moon was formed. Okay, so this was the theory. Next. You know the moon in human civilizations because it has impacted our so many theories will be there. You may be knowing that moon actually affects our mood, then poetry, life, everything. Okay, even the moon calendar is there. You know that lunar calendars still we are following. There are two types of calendars. One is the lunar calendar and another is solar calendar. So still moon, the rotation, revolution of the moon also we are still following till today. Next. And why we see only one face of the moon? You know that phenomenon is called tidal locking because this is called synchronous rotations. The tidal locking is the name given to the situation where the object's orbital actually parent meshes with the rotational parent. So when it rotates, moon also rotates on axis and it also revolves around the Earth. So these two parents are actually same with approximately 28 days. So therefore, moon we only see only one face of the moon. Next. So these are the two. What we see today is called the near side. What we do not see is called the far side. So what we see today, both are having mare as well as highlands because two areas are there. What we see the black spots are called the mare because they are behaving like a ocean. Okay, and others are called highlands. So what we see today, the black spots basically are the craters. Okay, so the light was not able to come reflect properly from there. Next. So is the moon hot or cold? Yeah, so both. Moon is very hot during daytime. It is almost touching 120 degrees centigrade. So when you give water, it immediately boils. So it is like a microwave oven during daytime and a refrigerator during night time. It is minus 180 degrees centigrade. It is called actually in technology terms called cryotemperature because cryogenic temperature means a temperature below minus 150 is called cryogenic temperature. So moon night time is very cold, we cannot survive. So this also has important relevance to the Chandrayaan mission. You know that the mission of the light is 14 days only. Yeah, so this minus 180 has an impact on the life of the Chandrayaan mission. Okay, because nighttime survival is very, very difficult without the external heat source. So this is very important. Nighttime survival is very, very challenging on the moon because it is touching minus 180 degrees centigrade. Even let us say not nighttime. Then what about the permanently shadow regions? Because in craters and all those things where light is not able to reach, even it is reaching minus 240 degrees centigrade. It's much more than that. Okay, so we cannot survive there. So is you may be knowing about this one Newton's experiments. When you drop, moon is almost vacuum. When you drop one heavy object and a light object, Because when they drop here, they are falling at different time. But if you drop in the vacuum, like moon, they will reach at the same time. So these are experiments, even astronauts during NASA time, they have done the experiment. It was dropped and they were reaching at the same time. So this is actually, moon is a very natural vacuum, so natural laboratory for us. Next slide. And the moon, once upon a time, it was actually closer to us. Now it is actually leaving us, slowly receding from us. Next slide. So this was the moon 1000 years after its formation, and today's moon after 4.5 billion years. So moon was very actually big because it was closer to us, and now it is very small, and it will be smaller and smaller because moon is reaching at a rate of 3.8 centimeters per year. So after actually our generations, they will be seeing smaller and smaller moons. Okay, the size. Yeah, next. So this is we call it eccentricity, class 11, 12 students, you may be knowing, this eccentricity is a parameter which says the circularity of the, the orbit. So if the eccentricity is very close to the zero, then it's more circular, and then other it will be ellipse. So if you see the 1000, earlier it was actually 1000 years after the moon formation, it was very circular, then after it's elliptical, then now it is again closer, back to the closer. Okay, circular. Next. So then why do scientists find moon interesting? I told you that moon is a natural laboratory because it is airless body and there is no global magnetic field like us, because Earth is having magnetic field, but moon does not have a magnetic field, but it has a local magnetic field. Okay. So and moreover, easy to access orbiter. Okay, next slide. Yeah. I think projector was off mistakenly instead of changing the slides. Yeah.
Sorry for this technical glitch, but still with this technology, we are heading towards moon, depending upon the same technology. So it happens, but still kudos to our scientists who have been working really hard, and still they are working regularly, just like Mr. Raghu. And with this technology, we are aiming for our next missions as well. So just have a little patience. Maybe we'll get back with the presentation soon.
Yeah, I feel actually this is like a Chandrayaan to landing, because Chandrayaan to landing, when we are about to touch, the actually signal was lost. Okay, so I am about to start Chandrayaan missions, then then suddenly signal is lost, so communication. Correct. So, okay, the mistakes actually should happen for life to learn new things. So, this also is one example. So, let us continue. Okay, so this I think Moon is a natural laboratory to study the solar system because Moon and the solar system was formed almost at the same time, the 4.5 billion years ago. Yeah. Next. So these are the scientific motivations to study the moons because we need to understand the neutral and ion exosphere. Exosphere, you know, exosphere means when you have an atmosphere, the outermost layer is called the exosphere. Okay, so actually what happens is for moon there is no atmosphere, so we always call it the exosphere. You see, there is no atmosphere, and this we have to. Because I also told that we have to image the remote sensing, so we should understand. Then as well as surface studies and hydration, surface and exosphere. Hydration, you know that we want to understand whether water is there or not. That's called hydration phenomena. As well as the elemental compositions, what the moon rocks is made of, as well as what are the elements present there, and why we actually generally, you know, why we are going to moon. Because people consider the moon is actually very rich in helium resources. So like that only we should understand. So that is the reasons behind this to study the moons. Next slide. No, this actually PPT I will leave to audience who is interested. They can take it. No issues. Okay. Because of the constants. So what are the sources for information? We have the meteorites today. We have the sample returns because sample return missions are have been conducted during Apollo. Luna is done by Russians, and recently the Shanghai by this one China. So they have brought the lunar samples. So it is available in the labs, laboratory of the Earth. So we can study, we can know their rock formations, the compositions, elements, all those things. And in situ measurements, rover and lander today, because the rover can move on the surface, lander also can be there and do the surface studies. And remote sensing from an orbiter, because it will move around the orbit of the moon, then it also can do different actually studies. And another is telescopes. As you know, telescope also we can see, because this was actually first tool to study the moon. Before we know how to make the satellite, how to go to the moon. From telescope we see and we find out actually the other things. So who made a telescope first? Galileo, correct? So yeah. Next slide. The present lunar exosphere. You know, the moon is not static. Though it is not a livable, it's not a habitable, but it is not static. It is always dynamic. A lot of phenomena is happening at a scientific scale, because common men we may not know, but the scientific, the scientists in the scientific scales, a lot of phenomena is happening because it does not have an atmosphere, so it does not have the magnetic field. So whatever the solar winds coming from the sun, it is directly reaching the moon. Though moon and Earth actually at the same astronomical distance, one astronomical distance, you forget about the 384 kilometer, because 384 kilometer you compare with 150 million kilometer is very small. Like 1 rupee compared to 1 lakh is very, very small. No? So 1 rupee you can neglect. Right. So like that only. So moon and the Earth, we are at the same distance as compared from the sun. So what happened is we are habitable, but the moon is not habitable. Correct. But the moon, actually, the sun is emitting a lot of this one, like ions and energetic winds and all those things coming. But we are not having that one. But directly moon is having. So there is a lot of difference to study vis-a-vis moon as well as the Earth. So moon, the surface of moon is always dynamic, like sputtering, solar wind sputtering is the bombardment. Continuously in the atomic scale is being bombarded. A lot of craters are being formed. Small micro craters are being formed. Then photoionization effects are having. Photoelectric effect, you are aware of them, no? Photoelectric effect. So on the moon surface, also photoelectric effect is going on. So the moon surface is basically, you know, it is positively charged because electrons are kicked out. So moon surface is electrostatically charged, not like on the surface of the Earth. Okay, so it is very, very important for most missions like rover, because see, when the surface is electrostatically charged, you may be knowing that in your laboratory you have to wear a special actually because ice and all those things, electrostatic charge can damage it. So similarly, your rover actually electrostatic charge can damage. So like that only, it is very important to understand the electrostatic properties, surface properties, all those things. Okay, and there is also another. This actually I have put one line here between the dark and the white. That is called the termination line. It's called a terminator. Depending upon the sunlight, this line changes. So from one side to another side, actually the phenomenon is happening called hopping. Hopping is particle transportation from one side to another. So it will transport from here because of polarization effect. It will actually kick out and it will settle to the other side. So a lot of phenomena is happening, we should understand. And depending upon that, this rover is very small, you know. So if these particles are transported to the moon atmosphere, they will make a settle on the surface of the rover. It will damage the electronics. And moreover, it so transported the dust also. So if dust gets settled on the surface of the rover, your generation of your solar current will be limited. So like that, a lot of things are happening. Next slide. And let us come into the moon mission still left. So 140 missions, 11 countries till now. Okay, so this is the number. So till now, since 1969 American missions, the 11 countries have conducted 140 missions. So these are the 11 countries. You know that in chronological order, Soviet Union was the first, though United Nations have landed on the moon. So the Japan, then European Space Agency ESA, then China, then India. Luxembourg is a very small, country in Europe. And the actual beauty of this country is it allows everything. Okay, it is a very small, but it is a very business oriented. It does all space activities for commercial purpose. So it does not have any space agents like rockets and satellite, but it also participates in space agency in a commercial way. Okay, so Luxembourg is very important. Israel, Italy, South Korea, United Arab Emirates. You know that before Chandrayaan 3, what is the most recent mission was actually the UAE was trying to send a rover on the surface of the moon, but it did not succeed in landing. So that was actually from the one private company called iSpace from Japan. So they also did not succeed in landing. Okay, moon landing is very difficult. That I will tell you when we come to the moon missions why it is difficult in moon landing. Why basically some of the moon landings are actually failed. Okay, there is a specific reason for that. So next we will look into that. So moon missions, you see, know that the 140 countries. So mission-wise, United States have done everything. So they have done the orbiter, impact, the lander, rover, returns, and crew landing, everything. So the Soviet Union, they have not landed on the moon. No other countries have landed except the Americans. Okay. So where we are, India, we have lander and rover. We are we are about to land. Okay, the first attempts we failed, but now we are trying to land in Chandrayaan 3. So this is how is the status quo of this. Next slide. So there's a moon mission still there, 12 astronauts walk on the moon. This picture is the first, the left side is your Neil Armstrong. Second one is it will be unreal. The beauty part is Neil Armstrong, though he landed on the moon, these photos are very less because because nobody was there to take his photo. Okay, so he himself actually took Edwin's photo. So if you Google Edwin's photos, a lot of photos will be available because Neil Armstrong was taking very his photo Edwin's photos. Okay, so this is the lander which they have used, the digital lander. So next slide. So now coming to India's mission to moon. Okay, next slide. So we have conducted 3 missions till now. Chandrayaan 1, which was only orbiter. Chandrayaan 2, we attempted to land with rover, and there was also rover, baby rover inside the lander. And Chandrayaan 3, lander and rover. There is no orbiter. Okay. And next, maybe I think sample return missions. We don't know. Still, it's not yet conceived. Okay. Next. So Chandrayaan 1, it was a 10 months orbiter missions with an impactor because the impactor is called the Moon Impact Probe. So with the Moon Impact Probe, actually our tricolor Indian flag was dropped, okay, from the orbiter, and it landed on so India flag is available on the surface of the moon. So that shows that we are there. Wherever India flag is there, India is there. Okay, so that shows that. But not only dropping the Indian flag, so there was an experiment also. Okay, that is a moon impact probe. That actually experiment only found the presence of water. Okay, so there was a mass spectrometer. So the major findings are so that collaborative missions was ISRO, NASA, Americans and ESA, Germany, and UK, Sweden, and Bulgaria because there are payloads from there. Because there was posted payloads. There are 11 payloads altogether. And the major findings were discovery of this water. That was the breakthrough discovery. Other discoveries are there, but this was only scientifically important. So for our the common man, the water of moon was only the major breakthrough. Chandrayaan 2, it was a fully indigenous with orbiter and air payloads, and it was having lander and rover. That we cannot succeed in landing. Next slide. And the Chandrayaan 3, coming to the Chandrayaan 3. So what is the mission objective? It is a follow-on mission to the Chandrayaan 2. And it was launched in the 2023, July 14, by LVM-3 launch vehicle, the Mark 3, and we will be landing to the south latitude. This south latitude we have not declared yet. Okay, though the coordinates are known, latitude and longitudes are known, but we have not declared yet because what is happening is, though we attempt something, that moon landing, whatever we say, even Mars landing, basically it is in ellipse. It is not a precise landing. So there is one simple job that earlier rocket times, whenever Vikrant sir also told that, whenever initially such kind of sounding rockets or rockets are made, people always claim that it is always successful. Why? Because जहाँ पे जो लेना होता है वही target. इसलिए because there was no precise target. So इसलिए people always declare it is always successful. But when you say it is a precise landing, you have seen that SpaceX landing, how the Spanish stations coming in exactly landing on vertically, that is called a precise landing. So that is means it has to point landing. So there is a two types of landing. One is actually very precise landing. Another is conventional landing. So it will be like an ellipse. Okay. So our mission life is only 14 days. So next we will come to that why is limited only 14 days. Next slide. So this was the Chandrayaan 1. So I told you that there was a moon impact probe. So which was dropped on the surface of the moon along with the Indian flag. There were 11 payloads. The 5 are from India and other countries, Europeans, United States, and other states. Okay, so we will not go through in detail. Next slide. We'll cover more on the Chandrayaan 3. Yeah. So these are the expansion of knowledge through Chandrayaan 1. The first image shows the hydrations. That shows actually the mineral mapping of the the moon. So the actually blue color are the polar regions. Polar regions, you know, the ice are there. So they are only actually it shows the hydroxyls, OH. Okay, the presence of OH. Therefore, it is a blue in color. Then this argon 40, the rightmost. So this shows the argon 40. Argon 40 from where it is coming is actually coming from the potassium 40. So when the moon was formed, actually when it is condensed, there was some small cracks and fissures are there. So potassium 40 is a radioactive. So radioactive means natural decay is there. So natural decay slowly is converted to argon and is coming out from the moon. So it is actually coming out slowly and it is made available in the exosphere on the surface as well as in core. So we have detected this also. No agency has found it. This is for the first time only India has detected argon 40 presence abundantly. Okay. Next, most of things are not in so these are the things, see, lava tubes, the lava means, that during the volcano, lavas are coming out. So when the moon was formed, it was very hot. So it's almost only lavas are there. When it was condensed, what happened is there is small fissures, the tubes are there. So these tubes are also very actually the huge. Even we can go inside and like a cave and we can stay here. Because why? What happened is this is quite insulating. Therefore, the temperature excursions. I told you that during daytime it is very hot and night time is very cold. So this is almost favorable. So we can consider this one of the habitable zones. So therefore, we are thinking that such fissures we cannot send our rover in a lander because these are very small. So we have to come with some rover called snake robots, snake rovers. So like a snake can go to the hole, no. So we are actually also thinking of this as kind of snake robot. We should go inside these lava tubes and find out what is there. Any such kind of a presence of light, signature of light is there, either extinct or extant. Okay. So these are very interesting from the scientific point of view. Next. So this is about the finding on the moon, molecular weight, finding of water on the moon. So molecular weight of water is in H2O is around 18. So it is also in the OH is also available. So we have to compare the intensity of this. OH and H2O, if you compare, it will be H2O will be 4 times stronger than the OH. So this actually your intensity shows the 4 times stronger. So that confirms the presence of water. That is how we have found. But very actually sad incidence is that when we found water, at the time actually what happened is like we are not very confident that whether our finding is correct or not. So ultimately, actually, the Americans were forced to declare this finding using our own data. So this is how actually the importance of publications. So I want to tell you to all that because you are actually the gems of our nations in the future. When you have some idea, you start publish. Once you start publish, it is registered in your name. This is the one opportunity which we missed basically. Though we found water for the first time, Americans, they declared they published first time. And again, we countered them. But what happened, see, counter is always, it takes time low. So next. So Chandrayaan 1, these are the craters we mapped. You see how big, how small, and on moon. Moon is everywhere crater only. Crater में crater है, अंदर में भी crater है, बाहर में भी crater है, crater का अंदर में भी crater है. Sub crater, all craters. Okay, so it is very difficult to land also because since lot of craters are there, Once you actually fail in somewhere, it will land you that inside the crater. So you cannot actually say that your mission is successful. So it is very difficult. Next. So Chandrayaan 2 orbital. Again, this also having only the this mineralogy mappers, elemental compositions, almost the extension of the Chandrayaan 1. So next. Yeah. So this is another big crater. We call it as a Hagacious crater. See, light is not coming out. It is very big. It is actually, the scale is 400 meter. So Chandrayaan 2 has captured this photo. Next slide. This is most pictures only. These are the boulders unsafe for landing. See, these are actually, these big rocks are there. So one is when the lander leg, okay, falls in one of the boulders because your stability is going to be compromised. So again, it will topple it. Correct. So it is very difficult because moon surface is not a very smooth like our surface. So that says that it is unsafe for landing. Is taken by the Chandrayaan 2. Next slide. So this is another crater. You see the terrain mapping camera has crater, and the LRO is a NASA orbiter. This is available on the lunar orbit. Okay. So next. Now coming to the mission Chandrayaan. Next slide. So mission objective is, it is a threefold mission objective. One, I think you know better than me about Chandrayaan 3 because I see the ecosystems and all those things. But nevertheless, that will interact with each other. So okay, so it's a threefold objective. Number one is we want to demonstrate a safe and a soft landing on the lunar surface with a lander, and number two is to demonstrate rover roving on the moon, because rover roving on the moon is also not easy, because whenever you have to move means there will be a wheel soil interactions. Correct. When the soil is very loose, you cannot move, no? Correct, on the surface. So therefore, wheel soil interaction is very important. So we want to demonstrate the roving on the moon. Okay, moon soil. Moon soil is called regolith, and the properties are very sticky, and it is electrostatically charged. And once it sticks, you cannot actually blow also by fan. You have to actually remove electrostatically. So the moon soil, the regolith, is very unique in property in terms of its adhesions and in terms of its electrostatic properties. Okay. So next slide. So Chandrayaan 2, how is helping the Chandrayaan 3 missions? Chandrayaan 2, orbiter is still available. So Chandrayaan 2 will help the Chandrayaan 3 mission in terms of communications. Because the rover has to, because the data, whatever the lander and the rover is collecting the data, it has to make available to us, no? Then only we can see that. So this communication directly we cannot communicate from the lander and the rover to Earth. Okay. So this lander and rover will communicate to the orbiter which is available on the Earth, and orbiter will send to Earth. Okay, this way the orbiter will help the Chandrayaan 2 missions. Next slide. So how we are going? This is the mission sequence. You know that there are three actual phases. One is Earth-centric phase. So the left side.
Show your excitement with a huge round of applause. We shall continue.
Thank you. So we have three phases. One is Earth-centric phase, another is the lunar transfer phase, another is the moon-centric phase. Okay, the left side shows Earth-centric because your Chandrayaan 3 will be orbiting around the Earth. Then after that, it is again going to the moon. So that is the lunar transfer trajectory. Okay. Then after that, it is again circling, actually making rounds and rounds around the moon. That is the moon-centric phase. After that, only we will be landing. Okay. So what is the distance between the moon and Earth? 384,000 kilometers. Okay. So let us see. So this actually shows that how we are separating once we reach the moon. So we'll come into details in the subsequent slides. Next. So this is how we are landing. Okay, so you know that 100 by 100 kilometer, and today's orbit is 116 by 157 kilometers as on today. So we are very close to landing. So we are actually targeting to land on the August 23rd. It will start from 5:47 p.m. Okay, so but the landing will start from 100 by 30 kilometers. So these 30 kilometers, if you see the y-axis, this is the most challenging part. Because lot of important things are happening. The velocity at that time, you see the horizontal velocity BH of the lander craft is approximately 1.6 kilometer per second. From this velocity till touchdown, you have to bring it to the 0 meter per second. And the vertical velocity will be -1 meter per second. Okay, so bringing from 1 kilometer per second to 0 meter per second is not a challenge. This is a challenge. Okay, because what happens is this takes in a very small fraction of time. Okay, so a lot of activities here we don't have any control. These are all full autonomous. Everything, all actually programs, everything is loaded in the lander. So this is autonomous sequencing only. So first it will come to the rough braking phase around 690 seconds, and from this rough braking phase it will come to the 7.4 kilometer. This orbit, and it will reduce the velocity of 358 meter per second. Rough braking means when you drive a car, we put a brake, but here actually there is no brake, correct? No. So how to apply brake here? Because you have to actually fire the thruster in opposite directions. Then only you are reducing the velocity. Okay. So Newton's third law of motion, you know, action and reactions are equal in opposite magnitude. So we are firing the thrusters in opposite direction so that the velocity is reduced. Okay, so this is how we are reducing the braking system. Then will come to this the attitude hole and a phase. So from here again continuously we are imaging it. So there are certain actually sensors are there called continuously will be sensing that is called altimeter. So when we are descending that, we will know that at what kilometer I am here. Okay, so that will be measured by altimeter. So that is RF as well as optical altimeters are there. And I should know what velocity I am measuring. So that is called velocimeters. As well as I also should know continuously that where I am landing. That will be actually the hazard avoidance camera. So continuously what happens is I will be imaging whether I am near to the crater, I am near to the boulder, whether I am near to the plain area, and what is my velocity, where I am. All these are actually the closed loop system. Then after that only I will take decision that I will land. Otherwise, I will actually here hovering. You can see here 22 seconds before landing. So hovering means like helicopter. You will be actually hovering around the surface and see whether I am safe for landing. If I am not safe, then again I will take another actually nearby area, see whether I am safe for landing. Okay. So this continuous process is very challenging. This is where actually the crux of the mission is there. But if you see the Chandrayaan 2 also, the coming closer to the 100 by 100 kilometer, even reboosting was there. So there is nothing new till today. So what we are actually experiencing, the success, all these things from this 30 kilometer, this mission sequence. So this will be controlled and this will be observed from the Bangalore. You know, sir may be knowing that straight. We have the ISRO telemetry and tracking command system in Kenya. So it was very close to where my office is, the ISRO headquarters. From there only we are actually mission control system is there. So this is how actually we are, and so again see hovering, then after that retargeting 52 seconds, again retargeting vertical distance. So this is how we are landing. So if we are not achieving this, suppose if we land at 1 meter per second, so my target is 0 meter per second. The 0 meter per second means slowly I should land without any horizontal velocity. Why? Because my legs should not be damaged. Otherwise, actually my leg will be fractured. So my leg fracture means lander will be in different positions. So lander will be in different positions. Why? Because antennas are mounted in different directions. So if my eyes are here, I cannot communicate to you, correct? So therefore, the lander cannot communicate to the orbiter. So this also called for the failure of the mission. So therefore, my leg also should be safe. I should be landing safely means my leg should be in the proper position to all the four legs. So this, therefore, I will be continuously observing where is the safe landing area within that region. Next slide. So this is the see basically if you see here you know there are four modules are there. One is a propulsion module, another is the lander module, another is a rover module. Okay, so actually the lander and rover is the mother and baby configurations. Rover is inside the lander and it will come out as you actually put here. So this propulsion module means that this basically this is like a semi orbiter. Okay, orbiter means this also will carry the composite module of rover and lander from Earth to the moon, and it will actually yesterday it was separated. Yesterday it was separated means they got divorced. Okay, so so what happened is this will carry, but this also will be there in orbit for 3 to 4 months. This has a payload called a sail. Sail means it will see the Earth from moon, from the moon orbit to see Earth. Because when we see exoplanets, have you heard about exoplanets? Because exoplanets means like our planet. There are so many, we are thinking that so many exoplanets, like habitable planets may be there. But what is the signature of these habitable planets? Because the best example near to us is our Earth. So if we look at Earth from a distance, then if I find out that these are the signatures of a planet which is habitable, then I can compare these conditions with other planets, exoplanets, and derive that this infer that this planet will be habitable. So this propulsion module, I can understand. Okay. Yeah. This propulsion module is having one payload called a SAFE, which will continuously look to the light reflected from the Earth and see the habitability conditions to find out the exoplanet conditions. Okay. gravity of the moon is 1/6. And 1/6 is very, very important. I feel that actually God has intentionally made it 1/6, okay, to make it difficult for landing, because 1/6 has a very, very important role in landing. So now coming to the slides, we'll come to those details. Yeah, next. So this propulsion module, so this will remain in orbit for 3 to 2 months. It will be continuous observing our Earth for habitability situations, conditions. Next slide. Big change. Next slide, please. Yeah. So this is the lander, this is the actual hardware which we have realized, not the artistic picture. So this also the lunar, actually rover, actual one. So the lander is having the 14 Earth days, and is the same rover also 14 Earth days. Why 14 Earth days? Because on the moon surface, the number of, actually the moon has only 12 days. So one moon day is equal to 1 month of the Earth. So like 12 months of the Earth, moon has only one, this one, 12 days. So one moon day, depending upon again how much sunlight is available, or if you are an equator of the moon, you are having 14 days sunlight and 14 days night. So depending upon the latitude and the longitude, so your number of days varies. So if you are at the South Pole, so therefore South Pole there is actually you see if the South Pole our solar rays are coming tangentially. That's called grazing. So therefore continuously the sunlight will be available. So that is called permanently sunlit area in the South Pole region. Therefore we are going to near to the South Pole so that we'll maximize the number of sunlit days. Okay, that is one of the regions. Yeah. So these are the lander payloads. Lander payload is having 3 payloads. One payload is called Ramba. So this will see the ions and electron density, and the Saste means the thermal properties of the lunar surface. And this is the moonquake. Like earthquake, moon is also having a quake, but it's a small intensity. Okay, the small research. Next slide. So the rover is having 2 payloads. One is called the Apex, another is the LIPS, that is a laser induced breakdown spectroscopy, alpha particle X-ray. So they will do the elemental as well as the chemical compositions of the moons. Okay. So next slide. This is LVM3. You know that it is actually 3-stage launch vehicle, which is having the liquid, cryo as well as the solid. Okay. So this is the most reliable launch vehicle ISRO has. So with this only we are able to do all the commercial activities as well till today. So the next slide. Yeah, these are the different stages. Yeah, next slide. Yeah, this is model, lander model. These are engineering diagrams. So how is the composite models? So they actually stack together, and this is the lander craft, and this is the exploded view of this propulsion model. So next slide. This is the lander model. How these various the instruments are mounted on the lander. So it should have all the sensors, like we are having sensors, eyes and then air, nose, everything. These are also sensors for us. So he also should have all the sensors. I told you that this continuously that laser altimeter is mounted here in this left side. So this will continuously monitor the altitude. Okay. Then like the Saste payload is there. Then thermal physical properties. Then antenna, carbon antennas are there. Ramba payload is mounted on the right side. Then horizontal velocity camera. This is how actually things are mounted on the surface of the lander, and how the rover will be coming out. Actually, the replica you have already kept here, because this is in the stall conditions. Once it reaches the moon, it will. Once it reaches the moon, what happens is we'll wait for some time, because what happens is it is having actually the 4 thrusters, tracking thrusters, 800 Newton capacity. So when we land on the moon, lot of dust will be generated. Okay, because when you fire, it is actually dusty surface. Lot of dust will be generated. So in order to avoid these dust, and you can see that there is a, I don't know whether you observe or not, Chandrayaan 2 and Chandrayaan 3, there is major difference. In Chandrayaan 3, is actually 4 engines are there. In Chandrayaan 2, 5 engines were there. In a 5 engine, there one at the center. So actually that engine was also purposely kept, because what happened is, if you see the moon landing of Americans and Russians and even Chinese, all landings are done with a single engine, central engine. Okay, we are doing with a cluster engine. That is a 4 engine configuration of 800 Newton capacity. So this is the first time when India lands on the surface of the moon, not only technology, actually this one will be the first time which first country to land on the moon with a cluster engine. Okay, all other landings are with the central engine. Central engine means that this has actually good in the sense of stability, because when the central mounted engine in terms of dust and stability. But here what happens is these four engine configurations, when there is a small mismatch in the thrust, it will create a actually torque. Then it will actually try to topple it. So that is because the gravity of the moon is 1.6, is around 1.6 meter per second. So this is gravity is less means when the body is gravity is less means it behaves as if it is a floating body. Okay. So when it's a floating body, when we apply a small external force, coupled force, it will try to create a torque. So it will create imbalance and it will topple it. So this cluster engine, so therefore we are trying to minimize firing two engines simultaneously, so that this actually the torquing effect will be minimized, and as well as you will reduce the effect of dust. So once we land on the surface of the moon, this dust generation will settle after some time. So once this dust is settled, which is calculated that time, then this panel will open, then rover will come out. And the rover, next slide. Yeah, this is actually the exploded rover. So rover is having both sides solar panel. So one side is fully populated, other side is half populated. So one side can generate around 50 watts of power, other side can generate only 25 watts of power. So this is intentionally kept because for the first time rover is moving on the surface, we don't know actually how the mobility conditions and the survivability. So it may so happen that it may stop in condition which is not favorable for power generations. At a time, what happens is when sunlight comes, if solar cells are on either side, then power generation will happen. So then the battery charging also will happen. So that way, industrial is kept. So and moreover, you see, warm electronics box is very important because the rover is all the electronics are kept below the rover and the surface, and it is actually wrapped together with a warm electronic box because the temperature we want to control. And you may not be actually knowing that here also we have put one experimental passive heat source which will be testing for the first time, which will continuously generate even during night time also. So, but that watt, that is only 1 watt, which is not sufficient for nighttime survival. If you want to control the temperature up to minus 30 degrees centigrade, we need a minimum around 16 watts of power. So we are not having that much of power. Because of that only, we are actually planning for only sunlit days and 14-hour days. But nevertheless, it is unquote. We also have the sleep and wake up circuit. Okay, sleep and wake up circuit means this electronically designed circuit. So we are trying for the first time that suppose that nighttime temperature is very well below minus 180. So electronics will not work below minus 50 or minus 50 degrees centigrade. So all electronics will stop. But next time when sunlight comes, so whatever the solar power generations will go to the warm to make the electronics warm. Then after that we charge the battery. So electronics design is there, that is called sleep and wake up circuit. But it's not actually, we have not make it public. Okay. So but for the first time we'll be testing that one. If that works, our life will be extended more another 14 days. Yeah. So I think sleep and wake up circuit is working. Gravity is 1/6 of the Earth. So we also have to do the rover mobility on the 1/6 gravity conditions. That we have done experiments with the helium balloon. So we have inflated the balloon in such way that 5/6 of that one will be actually taking out from that gravity, so that 1/6 will be remaining, and we have done the mobility along with the balloon. So that is how we did for the rover mobility part. And for this test, which I not covered here, is we have done extensive test for this lander, because earlier the Chandrayaan 2 lander legs were designed for survival up to 1 meter per second impact. But now the lander legs are very actually strengthened. It can survive up to 2 meter velocity, to 2 meter per second velocity impact also. So therefore, now this time we are very hopeful that we'll be actually landing perfectly, and will be actually the pride for the country. And and the Russians also is coming on Luna 25, so they'll be reaching before us. That is what it's almost competition. Yes, yes, yeah, exactly, madam. So, and for them it takes only 10 days, 11 days basically, and for us is 40 days, because the difference is the power of the rocket. Because the rocket they use a very powerful one, Soyuz rocket they use it, and they can actually put the spacecraft in a much higher orbit, very closer to the moon, so they can reach moon faster. Even if you see the 1969 Apollo landing, it took only 4 days for them. July 16 launch and July 20 they were able to land. I think hopefully. Okay, next slide will go. I think, yeah. Oh, okay, these are some of the pictures which actually done in the ISRO Supply Center. That is called EUR Supply Center in Bangalore. The actual testing was done. Next slide. Yeah. So this is how the transported our Vikansara also has put how the rocket rocket was transported and how the size you see the huge rocket. Okay. So that next slide. This actually I want to see. This is that our the Sriharikota launch pad. The how the actually the launch pad we have. Next slide. Yeah, this is the July 14 the launch day. The next. So mission chronology wise, if you see here, yeah, we started from on July 14. Then after that, we actually the July 15 was the last outbound maneuvering. Then after that, actually the lunar trans injection has happened. So next slide. So on August 1, the lunar trans injection was happened, orbit insertions, and lunar orbit insertion happened on August 5th, which is actually the last orbit is 100 by 100 kilometer. Today's orbit is 111 by 157 kilometer. Yeah, next slide. So this is the chronology. See, this is actually photo on the August 16th, 8:30 hours. So morning. So this is the outbound maneuvering. So on this 153 by 163 kilometer. Next slide. So this on August 17th. So this is how actually they are separated from 160 to 160 kilometers. So you see the right side, actually the propulsion module is orbiting in that 153 by 160, and the lander is descending towards the moon, approaching to 100 by 100 kilometers. Yes. Next. So these are the first image taken actually by us, the Chandrayaan 3 on the launch day. The image of the Earth is the latest image taken by Chandrayaan, the propulsion module on August 6. Okay, the horizontal velocity camera. Next, so you can see the craters. So the present, what are the missions actively on the moon? So these LRO is there from NASA, which is orbiter, and another is Chandrayaan 2 is an orbiter from China. Actually, one U2 rover as well as this another Chang'e lander is there, and Chandrayaan 3 is on en route, as well as the Luna 25 Russia is also on en route. These are the missions which are actively operating on moon. So I want to here, let us see here, the madam, you are also asking about Luna 25 and Chandrayaan 3, how we do compare it. Okay. So here you see landing site, you see you see here 69 is almost 69 degrees south latitude, and there you see here their landing site is almost near the lunar limb, that is called the Bogolsky crater, near to that. Ours are also very close, only the latitude is same. Longitude wise, there is little difference is there, but we are very close to each other. So we will be landing. They will be trying to land from 18 by 100 kilometers closer. We are landing from 30 by 100 kilometers. So for them, it took only next slide, please. So this slide also be useful. So we will leave it. Yeah. So here you see the slide. They are August 10, they started landing. They are trying on 21st August, 11 days. For us, July 14, landing on 40 days. Okay. So mission, you see trajectory. How many burns for us? How many actually, you see, orbits, how many attempts? For them, you see, only 1 or 2. So this actually shows that how powerful their rockets are. Because they are actually launching very close to the Earth. Then after that, only one circularization has happened. Then directly going to the lunar trans orbit. then lunar orbit insertions, then after that attained by 100 kilometer they will be landing. Okay, next slide. So coming to the Aditya mission, this is a mission to moon. You know that Lagrange points. Okay, this also you please study. Lagrange points are very interesting. So Euler Lagrange, one mathematician, has actually found this Lagrange point. Whenever two body systems are there, okay, so we have to consider as a two body problems. We have to solve in such way that when one small body is put to the around the actually the gravitational field of this bigger body, there are certain points where your gravitational actually effect or otherwise the drag is very minimal. That is in terms of fuel consumption. So it is very fuel efficient. Okay, so here actually the for the Earth and the Sun, there are 5 Lagrange points are there. So we are going to the L1 Lagrange point because we want continuously observe the Sun. And you know James Webb telescope. So it is going in the L2 because he wants to away from the sun. Because what happens is he is actually infrared imager. So he wants the infrared imager means he wants to be actually the very cold. So if he is behind the Earth, then only he can remain cold. So because of that, only he is going to the L2 orbit. Okay, this L3 is called the spy orbit because some actually spacecraft will go there and hide and see that because from Earth we cannot see this L3. Okay, so therefore some actually spacecrafts are purposefully put there as a spy spacecraft to see the other activities. And L4 and L5 are basically they are very stable orbits, and other L1, L2, L3s are not stable orbits. A lot of interactions. But another is actually we have ruggedized this leather legs which can withstand up to 2 meter per second impact. That is one. At that time, two was designed was only for 1 meter per second impact. That is one thing. Another is actually all the softwares, everything also we have improved. Okay, these are the measure. And another is we have introduced here many more sensors in this. And one interesting part is is listed here. One more payload is there. That's called passive payload. This is called retro reflector. It's put by America on our leather craft. This has a purpose. Retro reflector, the example is retro reflectors means when you see the mirror, what is happening? The angle of incidence is equal to angle of reflection. So here also the same thing. But here what is happening? Retro reflectors. When light actually comes from that, light falls on the surface, in the same angle will come back. If it falls 90 degree, it will come back 90 degree, 30 degree, 30 degree, 60, 60. The best example is you see in the road, you will see on that traffic signals, there are some reflectors are kept on the road. Those are the retro reflectors. So Americans has put one small retro reflector here. The purpose is that whenever other next missions are coming, so the light when it is here, it will reflect there. So they will know that where exactly this lander is there. So that is the purpose of the retro reflectors. So this is the basic payload is like a small mirror, but purposefully is kept to locate the location of this our lander subsequently by other missions next time when it comes. Okay. Madam, actually, Luna is only lander. It does not have any rover. Okay. So the objective wise also almost same only. They also will be elemental compositions, then analysis. Okay. But we have additional like capacity rover. So which will be moving around at velocity of 1 meter per second. So in a vicinity of around 500 meters, we will be moving and communicating with the lander, and lander will feedback. But otherwise, if you see the landers, actually the aims and objectives both are almost similar. Because it is stationary, they are not moving. Yeah. Yeah. Thank you. It is very interesting questions. So nice to actually hear these questions. Nuclear reactors, nuclear. That is a good part. How I will explain to you. Nuclear reactors means they do not need any hot or cold conditions. They will work. That is called the natural decay. Okay. So when you have one nuclear fuel, automatically it will decay slowly, irrespective of where it is, how hot, how cold it is. So these technologies called there are two types of technologies. One is called RHU, radioisotope heating unit. Another is called RTC, radioisotope thermoelectric generator. So in RHU means it only supplies heat. Okay, it will make you only warm, not coal. Okay, it will make you only warm because it generates heat. In RTG, what happens is this heat will be converted to electricity using one actually device called the thermoelectric generator. Is called we call as a okay. So uh, uh, it's called the TEG. That is the thermoelectric generator. Okay. So there are actually what is happening is in India the fuel of the nuclear reactor. There are three fuels are required. One is plutonium-238, another is americium-241, another is called strontium-90. So if you see the technology, the availability of this fuel, plutonium-238 is only available in Russia and America. Okay, we do not have even no country having sufficient fuel. So, and in terms of I will come to that. Okay, your last final answer I will come to. But for audience, while we're waiting. So americium 241, since no country is having, we are actually what is that migrating from plutonium 238 to americium 241. Even Europeans are actually migrating from this plutonium 238 to americium 241. Strontium is not used because strontium is actually it is very hazardous for health. So it is only for ground purpose. For the space purpose, it cannot be used because it is very big in size. So if you come to this point, basically we have developed, means our country has developed only RHU, that is heating source. This technology is only the trial stage. It's a qualification stage. We have not reached up to the RTC. And RTG, we cannot buy from other countries because of the strategic reasons, because no country wants to sell this. Okay. So therefore, in our missions, we could not put this radioactive source generator or heat source because we do not have this technology as on today. But nevertheless, we are developing it. So next missions, we will be able to see. Because of that, only Russians are having 1 year mission life. We are having only 14 days mission life because we do not have any heat source to survive in this night conditions, which is close to minus 180. Okay, so the answer is at present today we do not have this technology, nuclear technology, to survive or to heat the systems to convert to electricity. But in next missions, we'll be definitely having. Okay. Yeah. So I think we'll go to the next because it is keeps on sending. This is another expo set which will be launching. Both Aditya and this one sir will be launching this year only. Okay. So this will only see the X-rays. You know how the black holes are identified. Black holes we cannot see. So black hole continues to emit its X-ray. That is called accretion beams. Okay. So in the event horizon, so beyond that, accretion beams means it will generate continuously X-rays. From that X-ray only we can identify the whether black holes are there or not. So such kind of missions we are also actually attempting this year to be launched. Next slide. So this is the Chandrayaan because I am also told that we should include 1-2 slides of the Chandrayaan. 2 slides are there. So this is how actually we will learn going into space. Our astronauts will go to space and come to Earth again after 5 or 6 days, 1 week time. Okay, next slide. So this Chandrayaan, basically we are also not doing. It is actually collaboration of ISRO, academia, industries, and then actually France is actually supporting us. Russia is supporting us. Then other actually the private companies like Amazon, they are supporting for ground stations because what happens is, see, ground station support is very much required. When the satellite is in orbit, when the astronaut is in orbit, your line actually is there. So the astronaut and us, we should be continuously taught. Like when you are away, your mother will be always calling, how are you? And where are you? And all those things. So astronauts, when they are in space, we have to continuously contact with them. So from Earth, we can see only certain part. So other part we cannot see. So other actual people have to contact and tell us, okay, your astronauts are safe. So therefore, ground station supports are very much important. Next slide. Next slide. Yeah. So this is the career part, that see, all we do today is actually leading to the careers. So ultimately, what happens is we also wish you should have all these good careers in life. That is the wish of all parents. So ultimately, we have to see that is there any career opportunity in space? Okay, space sector. So we have all these communication, entertainment, banking, and internet services. What we do today is because of the satellites, and satellites made by the scientists in India. Next slide. This okay. So the different sectors. Next slide. Yeah, there are two types of the careers. One is salary worker like me. I get salary. I'm working for the government of India, and another is the entrepreneur. Like you create jobs. Actually, you create jobs and you provide jobs. So there are two types here. So you can be both, or otherwise either of these one. Okay, depending upon your choice. Yeah, please next. So the space sectors they contribute to global space economy. Next slide. Actually, the global space economy, we have the launch cycle, then ground infrastructure and the space segment, and ground segment and the launch vehicle segments. Yeah, next. And the global space economy today is $450 billion US. So in the 2047, means 2047, why it is very important? Because India got independent in 1947. So we are actually will be reaching 100 years. So our country is targeting self-reliant country. Okay. In 2047. So there in 2047, our global economy will reach 1.5 trillion. Trillions, you know how many actually zeros that we already discussed. Next, yeah. So these are the space centers. So space centers actually span across throughout India. So you can visit any one of these. And see, there is opportunity for now. Actually, under this one, so is there until New Space India Limited and the In Space also has come. So we have all these branches. The next. And the recruitment and staff and helpers, all actually sectors. You have the scientists, engineers, staff, and even helpers, all actually job opportunities are there next. So dreaming of the working in ISRO, so we have, when there is an announcement, we always post in the isro.gov.in, so we can browse anytime. So next slide. So you see, there are a lot of things are there. Astronaut, astronomer, astrophysicist, astrobiologist, aerospace engineer, space doctors, then the mechanical engineer, electrical, all these branches, space lawyers, even lawyers actually they have a lot of engagements in space laws, in framing space laws. So next slide. So this is astronaut. Astronaut should have actually he should have perfect vision, he should have good education. Astronaut simply one person cannot be astronaut. Okay, see, he should have all these qualities. He should have very good education. He should be physically fit, academically fit, as well as mentally fit. All these are very important. Yeah, next slide. And these are Indian origin astronauts, that our Rakesh Sharma, sir, he was the first astronaut actually flown in Russian Soyuz. Then Kalpana Chawla, then Sunita Williams and Raja Chari space tech. Kalpana Chawla, madam, is no more, disaster. So next slide. Yeah. So if you have a BTech degree, really there is a career in space. Next slide. Yeah, all these branches of engineering, they have all equal job opportunities in the space sector. Next slide. Even metallurgical studies, we have the job opportunities. Next slide. Even doctors, because doctors, when we do the International Space Station, even actually doctors are going as astronauts. Because whenever you have something, because they have to attend. And there is one very good technology. Have you heard about holoportation? Holoportation is a very good technology. Now, actually, Americans, they have demonstrated first in this station. Okay, International Space Station. So what is happening is, when you are here, you can transport yourself to the space. And you can interact as if you are physically present there. This is called holoportation. It's very interesting. You read about this one. First time only recently, last year, Americans, they have demonstrated. And they have transported a doctor, physician from Earth to International Space Station. Okay, to actually attend. So we are also planning honorable, actually, our dignitaries, honorable PM kind of things. We can actually transport during holoportation from here to our Gaganyaan missions and interact with our astronauts. Correct. So it will be very interesting. Correct. So this is a very interesting technology. You read about that. Next. And space laws is very interesting because whenever space debris falls, there's a lot of issues comes. So space laws are very interesting. Next slide. Okay. I think we'll wind up. Yeah. Yes. Actually, there are some videos are there. If a slide actually with visuals, 1-2 videos with how the orbit insertion has those things, also we can play for 1-2 minutes. Otherwise, we'll wind up. Thank you all, yeah, for giving me this opportunity to interact with you. Yeah, thank you.
You know, what was left by Chandrayaan 2 mission is now accomplishing by Chandrayaan 3 mission. And that dedication and vision I can see from the man himself. Thank you so much, sir, for your kindness, your immense patience. And I know I'm glad that slides got resumed because we were so into it. Even though the technical glitches gave us some moment to laugh and, of course, to remember, I feel very honored to listen to the man himself today. Thank you so much, sir. A huge round of applause for sir. Okay, let's move further. So our CMD of Space India, Dr. Sachin Bamba, is an Indian-born and entrepreneur and philanthropist who has been pioneer in introducing the concept of astronomy and space science education. In the Indian education system, his passion and commitment to harness the potential of astronomy and space science in creating entrepreneurship and sustainable development. An avid astronomer and wildlife environmental conservationist, Dr. Sachin Bamba is a discipline of physics. He is a strong supporter of hands-on experiential teaching and learning methods in science and mathematics. He has introduced disruptive business concepts in the field of astronomy and space science education, astrotourism, and manufacturing. Now it's time to have a little chat with our honorable chief guest, Mr. N. Raghu Meetai, and I know you all are waiting for this moment. I would like to call Dr. Sachin Bamba along with our chief guest, Mr. N. Raghu Meetai, for fireside chat. I request the audience to show your excitement with a huge round of applause.
Okay, so we had a wonderful chat. Thank you, Dr. Raghu, for a wonderful chat. It was a long session and very interesting one. I think all of us are excited. We gave away so much information that, I have so many questions in my mind. So I'll start with thanking Bal Bharti for giving us this opportunity and this venue to bring you all together on this momentous time for India. So we are going to have Chandrayaan 3 launching in just 3 days. And I'm sure now this house is the most knowledgeable house. So I am called on many TV channels to explain things. And I now have so much asla in my pocket that, I can actually, there's a lot of people and you all are ready now. I know each of you wants to be an astronaut, an astronomer, and as Sir said, the possibilities are limitless with space. So you can be a space engineer, maybe a space writer, maybe a space poet, maybe a teacher, a plumber. There is everything we have to learn when we go to space. So we have to learn everything from scratch. And that would be what my talk would be around. So we just set simple rules. I think there are around 15 schools which are participating today. So I'll not take much time with my chat. I have curiosity in my mind. I'm a child still, though I am 50 now, but I still feel like a child. So I have a few questions for him. Try to bring out something that we can get more. And then I will leave it to the house. Maybe one question a school could be a possibility. And I'll give the last 15 minutes of this fireside chat for that purpose. And then there are educators and my staff will be very curious. So we'll take 4 questions from that staff. So maybe 20 questions means a huge, a big time chunk that we are looking at. So I'll restrict myself to limited questions that are there in my mind. So let's start with this fireside chat with a clap for the wonderful speaker that we have today. So ISRO, it's a pride. You know, as soon as somebody says ISRO's, चेहरे पे खुशी आ जाती है ना. So we feel pride. It's a gem of India, and it's a gem of India because the people who work at ISRO have very disciplined and dedicated schedule. I have visited ISRO many times. I have actually interacted with scientists, and once I go there, I see the passion that they have not only for what they do, the patriotism for the country and the dedication for the organization is something we all need to learn. I try to bring out that. So it's a gem, and the people who work there are pride of India. We are all proud of anybody who says that I work in ISRO. जैसे कोई सैनिक बोलता है मैं देश की रक्षा करता हूँ तो दिल में प्राइड आता है, ऐसी को बोलता है मैं इसरो के लिए काम करता हूँ तो दिल में प्राइड आता है. And we all want to work for ISRO, and we are all are working for ISRO. So I start with your journey, sir. So from, I was a very naughty kid in school. So, my question is directly to the kids who are naughty there. So, yes. How are you, sir, when you were studying your school life, your college life, and your IIT Guwahati life? So, I would like to know a little bit about
Yeah. Sir, actually, it's very interesting questions. Thanks for bringing that one. Basically, I must tell you that, see, there are actually different students. Their backgrounds are different. Some are born in rich family, some are born in poor family, some are born in village, some are born in city life. So their careers are different. However, the person if is dedicated, definitely you will reach to the destiny. Correct? So I am one of them. So I will just tell you, actually, I am also from, I belong to Manipur, that is northeastern, the border state. So what happened is I actually started my career in schooling in a government school. So at that time, sir also told that he is 50, I am 47. You may not believe that I am 47 completed. So in this journey, what happened is 47 years before the government school, there was no proper such kind of sitting place. Okay, there's such kind of tuitions and all those things. So and one more thing, it is very difficult because the English medium was not proper. So we started learning English along with our mother tongue, that is my language, Manipuri. So and Hindi, all these languages, slowly we started learning. So basically, it is a very interesting journey being born in a very, actually, what happened is a poor family. Basically, I am born in a poor family where my parents are not that much educated. So, but what happened is I was dedicated student. So I have a lot of interest. I must tell you that in this forum, have you heard about the Mir publication, Russia? So that was actually one of the books which have fascinated me about science. Today, actually, Mir publication is no longer available in Russia, but however, some of the books are available online. You please actually Google it. Most of the soft copies are available. You please download it. They have a lot of series called Science for Everyone. My brother, truly speaking, I will tell you, sir, very honestly, my brother has brought, he is not from science, okay. He brought one book, Science for Everyone, one book. That actually fascinated me like anything. Then I read, and today, till today, how many Mir books I have? I am a mate. In India, we only have 3-4 people who are fascinated about this, and we know each other, and we share also. I spent around more than 10 lakhs in collecting Mir books in my career. Okay, I went to Hyderabad buying books. My wife is telling, my home minister is telling I am mad. Okay, so my home minister is telling, why you have to do this much of books? Who will read? It so happened that I cannot bring the books to my home. I have to keep in a car dicky. And I have to bring one by one, slowly, when she is sleeping. So this is a situation that must have fascination, but all the books are gems. I actually must tell you that this is an opportunity for me to tell you, this is the right audience. Please actually read books. The Mir publication books is no longer available because they are not there, but online copies are available, and some of the second-hand bookstores is available. Please try to collect. These are very cheap, and the knowledge are enormous. And the last point, sir, if you permit me, last I'll tell you where I have transformed my life. Everything, I was very meritorious student. To the state, I was a position holder in my class 12 and in graduation. I was a second topper in the university. Then I came to IIT. I became a gold medalist. But when I became to IIT, first year when I joined, I was feeling always hungry. Because there is one book, written by our writer Rasmi Bansal. Stay hungry, stay foolish. Same happened to me. I was really hungry. IIT course, is very actually, the thing is very tight. Schedules are very tight, classes are very, this one, lot of activities are there, but since I am not able to adjust to the food, I was always very hungry. I could not. So one time I decided this very interesting story which has transformed my career. And the teacher is no longer with me because he is no more. He passed away in a very sad accident. So what happened is, the first semester somehow it got over. Second semester when it came, the first semester I was having a very good CGPA, but second semester I decided I will leave. Okay, anyway, जहां से भी मैं ग्रेजुएशन हो जाओ, मेरा अपना कुछ तो हो जाएगा. सो आईआईटी से क्या करेगा? सो मैं छोड़ने के लिए मतलब कोशिश किया. सो मैंने बोला सर मैं यहाँ पे रहना नहीं चाहता हूँ, मैं जा रहा हूँ घर. तो उसने कहा कि शाम को आ जाना मुझे मिलने के लिए. तो शाम को उसके चैम्बर में गया था. ही वाज अ हेड ऑफ डिपार्टमेंट लाइक आवर प्रिंसिपल मैडम जी. सो आई एंटर, सर मे आई कम इन सर. सो व्हेन आई एंटर ही टोल्ड या प्लीज कम एंड सिट डाउन. एंड ही आस्क्ड, he did not ask anything. He simply asked me, have you ever climbed a hill? This was only his question to me. Then I said, yes. What do you see once you reach the top of the hill? I told only valleys. This is where you are. You are climbing the hill. You are bound to have struggle. Once you reach the top of the hill, only valleys you will see. No more barriers, no more struggles. So then I have got new energy. I have decided to fight back. I stayed there. I got gold medal. And he was no longer, he passed away. So this is actually, I must tell you that this is the only question which has transformed my life. Have you ever climbed a hill? Okay, so I think you also please inspire, because I am having tears remembering that person who is no longer behind me.
Okay, guys. So this is an emotion that I also share with him, and I would like to say to the students, so you can have some report. So your teacher is the only individual in your life who does not want anything back from you. He's only there to give. Just try to figure it out. Your parents are still looking that there will be a future with you. You will earn someday. You will take care of them. But the teacher would only want a gratitude whenever you see the lady or the sir on road. Probably a namaste is what teacher is looking at, and each one of us is so much motivated by our teachers. I particularly is an example. I don't want to continue it. I also have tears in my eye for a particular teacher. So I think it would be lucky that we have teachers with us, and let's give a wonderful clap for the teachers who are present here. So making it a little light. Sir, what do you love being a scientist? I mean to say, you could be having something else. Probably you did your MSc from IIT Guwahati. You could have been an engineer. So what do you love? Was this journey the journey you wanted to take, or it happened? And if I give you a chance, would you want to be someone else?
Basically, you see, I will answer in this way. There are alphabets from A to Z. But life, okay. So see, life, what do you define life? Life is the actually timeline between birth and death. So the alphabet is between B and D. So what letter is there in between C? That is the choice you make. Okay. So C means the choice. That is B, C, D. So the life is between birth and death, and C alphabet is there. That is the choice you make. So either you choose to be a scientist, you choose to be engineer, you choose to be a poet, you choose to be another professions. So this is the choice you made that makes your life. So the same thing, I am also happy that basically what happened is, as I also told you that basically I was fascinated about science. So for the science people, there are many opportunities are there, but however, as sir also told that ISRO being actually the prime organizations for us. So I was selected for both the DRDO as well as ISRO, but I have opted for the ISRO. So simultaneously I got offer at the time. So I actually joined these professions with my will and enthusiasm, sir.
Given a chance, you still want to be an ISRO scientist and a scientist?
Yes, sir.
So let's go to understanding his professional life. One question, as I said, ISRO is a wonderful place to visit, not just to see the technology and the satellites and the rockets and launches, the way they work, the culture that they have. And you have worked for 17 years, means you have been through four chairmen, isn't it? Three, yes, three. So, just explain your life at ISRO, how do people work, how do you plan, and how things are happening there.
Yeah, sir, actually, see, ISRO almost we are having around 22 centers across India. But however, actually, some centers, you see, like we consider those are called odd centers in the sense that, like our launching Sriharikota. So these are very deserted area. So there are people working there. Basically, we also feel proud of them working there because there is no city life for them. And there is another place called the Mahendragiri IPRC, sir. You may be knowing of that one. It is also in a deserted area where animals are roaming. Even actually in between there are some caves are kept because whenever you sometimes when you are going, some animals you see, you have to hide in the caves. So this is the situation. That is the dedications we work. Okay. And moreover, whenever some project comes, because sir also told that see, ISRO is not a person, ISRO is an organization. When organization comes, teamwork comes, discipline comes, okay, leadership comes. So under one leadership, the teamwork, we always work as a team, under a team. So we always see, I cannot make a rocket. Not only me, one person cannot make rocket, one person cannot make a satellite. But all together we can make. That is what ISRO does. So, and moreover, for our working hours, as sir also asks, see, sometimes even for our office, like where I am there, our headquarters is our chairman's office. In one sense, it's like a PMO, sir, for us. Okay, PMO, the Prime Minister office for ISRO. So our entry time is fixed, 9:30 you have to be there, but exit time is not fixed. Sometimes we come at 9 p.m., sometimes we come at 10 p.m. So sometimes, no, that is I'm telling, is very difficult for us. Without cooperation from our Home Minister is really difficult. So this is a situation. Therefore, always you see, whenever there is a speech from the launch, they always give gratitude, thankfulness to the family members. Without their support, is not possible. So this is actually a lot of sacrifices happening. So this is what sir I want to say.
Okay, so ISRO, we saw that TV, we saw that experiment that was done. So we all know that what important role TV plays today, but we did not touch little more technologies because that flipping on and off of that could not highlight that. So I would like that people are still thinking sometimes. If I don't think deep, I still relate that rocket is not connected to me. I feel the pride, but I do not know what it is doing in my life. And you had a slide of 9 different things that ISRO is bringing to our life. I would like a little bit more light on how that is impacting day-to-day life of the people who are right here and the people who are not here. But it is very important for them to have satellites, fishing, mining, farming. So a little bit light on that.
Actually, how you see, ultimate aim of this space science or otherwise space missions. You see, one part is science, that is exploration part. We should try to understand our origins, our solar systems, and moreover, without one part, I'll tell you how the dinosaurs got extinct because of the impact of the yes. So like that only, if we don't know whether they are coming, when they are approaching, we also make it extinct sometime. So therefore, continuous monitoring is required. So that is how actually space science is required. That is one part. Another part is we also like you see, when some event is happening there, we also should be able to see what is happening. And when tsunami comes at a time earlier, so many people died. And today, so many lives are saved because we have evacuated on time. Tsunami is coming, we know well in before. Such kind of remote sensing. When fishermen are going, their lives are saved because tsunami is coming. Please come, please don't go for fishing. And moreover, in terms of economy, let us say agriculture and fishing. And fishermen should not simply go and do fishing because actually ocean is very vast. So there are certain fishing zones are there identified by our remote sensing satellites. And then we are actually indicating that here these potential fishing zones, please go and do fishing. And the meteorological satellites, today we know actually today whether when we are traveling to another city, we always see in the Google what will be the actual weather conditions. Truly speaking, in Bangalore, we are using the blanket. Since yesterday, I am always sweating here because it's quite different. And in Bangalore, we are using blanket and still night, but here it is quite different. So whenever we travel to another city, we always see there is a proverb, in the Second World War, how information is important. It looks like Second World War, when this some group of armies, if I remember, they did not know that Siberia was very cold. They died because of it. So they lost the battle. So information is very important. Such kind of information, telemedicine, agriculture, remote sensing, then our these fishings, meteorological, all informations are made available because of the satellites and space technology. Yes.
Okay, so you have little pieces. So I'll just engage them for a little time, a minute or two. So in his presentation, he missed something. What he does in ISRO is magic, and I would like you to have a glimpse of what he does. He will explain it. Not I cannot show you. Probably he's also not prepared. Doesn't have a slide. But there's something called ISRO quantum cell, and he is the focus point of it. Now I don't want to explain the technology because it is very, very interesting. I'm sure some of you will be inspired to understand what it is. And if you understand it now from the mouth of the person who is the focus of the technology, I think many of you will be inspired to take it now. And there are simple experiments that you can do in your physics labs. And let's hear from him what is quantum, ISRO quantum cell, and what is quantum communication. So, sir.
Thank you, sir. Yeah. I must tell you that in this actually quantum technologies is booming in the country. So you know that, okay, what do you mean by quantum? Quantum means actually discreteness. Okay, there is no continuity. It is not a continuous, it's a discrete. So what is happening is, have you heard about the superposition principle? Schrodinger cat is very interesting. So what it says that always two states always will be there because probability is there for both states. So you cannot say that if you keep one cat inside a box, closed box, you will never know whether cat is alive or dead. So you will know only when you open the box, only you will know whether the cat is alive or dead. So the measurements, you open the box is called the measurement. So whatever inside is called the state. So the state is called the superposition state. Means actually both possibilities are there and the possibilities are equally probable. Once you make the measurements, then only you will know what is actually happening. I will tell you one very simple example. You know the straight line equation y equal to mx plus c? Yes. So here actually the slope and intercept y equal to mx plus c. C is the intercept, m is the slope. So you will have a lot of straight lines you can fit in x and y axis, all possibilities depending upon correct number. So once you fix m is one number, c is one number, all the possibilities will collapse. You will get only one straight line. So this is a very beautiful example of this. So that is called the wave function collapse in quantum mechanics, that measurement makes the wave function collapse. All the probabilities exist. However, measurement makes only one possibility exist. And in terms of astronomy, I will connect in cosmology. Have you heard about the multiverse concept? Yes. Exactly, it comes from the quantum mechanics. Because quantum mechanics says that all the probabilities exist. So it is not only one universe. When we say universe, it is a single universe. When we say all the probabilities means so many universes may be there. So it's called the concept of the multiverse. So when you say the multiverse is coming from the quantum mechanics. Okay, so quantum mechanical principle. Now coming to the quantum communications, why it is important. Today when you do the WhatsApp chat, you may be knowing that this message is encrypted end to end. So that is called security. So when I want to, during war, during King's time, when one king send a message, let us say from actually our Jhansi ka Rani jo Rani thi, so उसने actually message उसके brother को भेजा था. अगर कोई intercept कर लिया, that means actually information will be known to the evil, correct? One eavesdropper, then their actually plan will be destroyed, correct? No. So information security is very important when I send a message. Therefore, the national security in terms of national security is very, very important. So how do we make this secure, one communication secure? Today, the security is built on the complexity of the mathematical functions. More the complex, more the security. Less the complex, less the security. But however, quantum computers are coming into picture. Quantum computers can hack this key in a very short time. So because of that, only our communications may not be no longer immune. Okay, so it will not be secure. Now we have to come with something secure which is not compromisable with any technological advance in future. So how to do it? Newton's laws of motion was valid in actually at that time also 16th century. 1665 he has actually postulated these laws. Today also it is valid. So we have to build this security using laws of quantum mechanics. Then only this security will not be hackable. So we are actually communicating, encrypting this communication key with the quantum mechanical principle. One principle called the Heisenberg's uncertainty principle. You may be aware of that one. Another is called entanglement method. And we'll be communicating from satellite in the LEO orbit to the ground station between two ground station cities in India. So, but for information actually for the audience, sir. So this communication has been demonstrated first by Japan using their Socrates satellite, and followed by the China using their Gracious satellite. So we are also trying to actually send this satellite in coming 1 or 2 years.
Thank you so much. So basically what he said was that there was a communication done at ISRO from one building to another, which was in light and side. And the communication was hack proof. So you cannot hack that communication. So even if I tell you I am communicating, you can't hack it. Whatever mathematics, because mathematics is taken out. Now quantum physics is coding whatever signals you are sending, and this has been demonstrated in India by ISRO. A wonderful feat under yourselves. So let's have a clapping for this wonderful feat. I'm sure this will be a technology, coming technology. So coming back to Sir Chandrayaan 2, we all know that there was a disaster, that our lander had some problems, and you also mentioned that it had a 5-engine configuration, and now we have a 4-engine configuration. So first, I would like to know, and everybody would like to know, what exactly happened in Chandrayaan 2? What have we learned? And why did you now choose not to have a central engine when you say it is a better configuration? Thank you.
Before answering these questions, I want to tell that our government of India has announced national quantum missions, officially with a 6,000 crore budget for 8 years missions. So ISRO also will be contributing to these extent. Yeah. So coming to this Chandrayaan 2 and Chandrayaan 3 about these central engine configurations, I told you during that time, because actually the most safe landing is demonstrated by all other countries using a single central engine. Since we don't have that much of capability, so we are using with a cluster engine. So what might happen in Chandrayaan 2, actually though different analysis came out with this one, certain inferences. So one of the probable reason is 2 engines, as I told you, sir, because when they fired in 2 engine configurations, if there is a small mismatch in their thrust, so it will create the torque, so it might have properly. So that is the one possible reasons apart from the software glitch and all those things, because these central engine configurations and the cluster engine configuration, first time we are actually trying to demonstrate it. And the central engine was put based on the dust issues, because the dust, when it is landing, when reducing from 1.6 kilometer to 0 meter per second, lot of dust is being generated. So when the central engine is fired, the dust generations will be in horizontal directions, not in the vertical directions. So, and moreover, it will be actually trying tangentially towards the surface. So when 2 engines are fired simultaneously, some of the dust will be trapped in between them, because their jet analysis has shown that. So I was one of the team member for doing such kind of analysis. So we found that whenever 2 engines are fired together, there is an certain amount of dust jet trap in between the 2 engines. So because of that only, but however, we feel that now we have improvised these engine configurations. So central engines we have removed and come to this, without this also, we have these optimized conditions will be able to land safely.
Thank you. So now we know that just 2 days from now, Chandrayaan 3 is going to land, and I would like to have it from your mouth. We already know we have not planned a return mission yet from Moon. So are we looking at Chandrayaan 4 with a return mission, and how soon do you think it is going to be a possibility?
Sir, this is very interesting questions. I also mentioned about that what next mission, because we have done orbiter missions, we have done the landing missions. If successful, we will be doing the rover missions. Then actually what next will be the sample return missions. So sample return mission, the most recent mission was Sangye 5 from the Chinese, okay, Chinese National Academy from Chinese Space Agency. So sample return missions, it needs a lot of robotics because what happens is you have to land there, come it, then after actually we have to again ascend from the surface and come to the orbit. Then again we have to transfer the sample because simply we cannot keep a sample, it should be in a vacuum low condition, sir. Then again transferred from the orbiter, transferred to the orbiter, then again orbiter again has to come back to re-entry situation. So it needs a docking and re-entry situation. For the re-entry part, actually, if we actually succeed in the Gaganyaan, as well as we have demonstrated one space return recovery capsule experiment, SRE experiment. So return mission, recovery, re-entry mission was demonstrated. But docking mission, as docking is concerned, we will be demonstrating one mission called SpaceX mission, sir. Once SpaceX mission is done, then only our docking mechanism will be qualified. After that, only we can take up such mission, sir.
So he's not confirming, he's not refusing. So we are looking at Chandrayaan 4, and that mission is an important mission for India because once you have an interplanetary mission, when we can go to another smaller land, some kind of land, and come back, would be actually a wonderful feat to achieve. And we look forward ISRO doing it very soon. So how many of you are around 17 here? 16, 17? Can I see? Show of hands. Oh, all of you. So it's an interesting time for all of you because I'll just sway him away from Chandrayaan to a little bit of Gaganyaan. So all of you are the potential astronauts. So right now this is the right age to win India because the space program is going and we are looking forward to a lot of experiments in sending humans to space. I always wished that I would be an astronaut. First problem was my height. 6'2" does not qualify. It's a trouble. And second is my weight. So other than education and the interest that you have in your studies, what you should study, I would say anyone who is below 6, 5'10" to 5'4", and can maintain their weight. Other than the studies, this is what qualifications you are looking at. So, sir, I would like to know about what is Gaganyaan exact plan and what is generally the future plan for human space flights in India.
Yes. Yeah. Sir, actually, before our main mission, that is called Gaganyaan, so we will be doing 2 unmanned missions. That is the plan. So the first actually technology demonstration, not the unmanned one. So technology demonstration we are planning to send in October itself. So that is the plan kept, and next will be, if everything goes well, again the missions will be, next flight will be followed in either January or February timeline. Then we will be flying these unmanned missions, 2 missions with the robots. What we have developed, okay, one half robot, okay. Then followed by the main missions. This is the plan. So in a couple of, like, suppose next year or the December timeline, hopefully we will be flying our completing unmanned missions. There is a timeline.
So once this Chandrayaan 3, the technological capacity that we are wanting to show happens, I see that there is a lot of possibility of tie-ups with other space agencies, particularly Japan. So we do not have an insight. So what are we looking at? In case India is able to demonstrate, in case, why should I say that? We are ready to demonstrate that technology, and what do we look forward with other space agencies, and what does that do to Indian economy?
Sir, actually, what you mentioned about the collaboration with Japan is called the LUPEX mission. Okay, we call it the LUPEX mission. So LUPEX mission is not yet officially announced, therefore much information is not available because it is a feasibility study. Because in the LUPEX mission, we will be providing our lander, and Japan will be providing the rocket as well as the rover. So these are collaborations between Japan and India. Once our landing technology is demonstrated, we will be able to say that we can provide lander to them. And their rover, and we also can make our rover. But what happens is actually in the international arena, most of these joint missions, okay, it is always better to carry out together because lot of things I tell you in office as well. Things do not work by posts, okay. Things only work by equations, by friendship. So therefore, if we have a good relations, good equations with space agencies, something or other, then we'll be helpful to each other. They have some technology excellence which we do not have. We have some technology excellence which they do not have. So therefore, on this basis only, we want to take up these missions together.
I had a question, but I'll just give that information away because that was something one of the teachers asked that question and he answered it. So why is our mission 14-day mission? Because sun will be available to our rover only for 14 days because moon is facing that way. It's a synchronous motion. We do not have an RTG. He already explained what RTG is. So radioactive thermo generator. We do not have that, so we cannot cool because there are both plus and minus 200 to plus 200 degree variations. And I would rather, from his mouth, I would rather tell that BARC has already entered MOU with ISRO that we will have an RTG very soon. So it is coming. I know he was part of that discussions going on, but BRC and ISRO are developing RTG, and all of this is happening because we want to have larger missions. Because Japan, as we are saying, will look forward to that technology in India. So I'll just talk about why is everybody so much interested in the southern lunar pole? So why is everybody going there? Why does every nation want to have a presence there?
Sir, actually, why people are interested in the lunar South Pole? Because these are the regions which left unexplored. Because you see, 140 missions, 11 countries. Most of these missions actually they landed on equatorial regions. Okay, that is one. See, there is no in mission. People always think that there is no fun of going to the same area where other already explored. Correct. Therefore, that is one reason. The first reason. Another second scientific reason is this is the managerial reason. First one. Second reason, technology reason, scientific reason is South Pole area. The polar regions, sunlight is because the lack of intensity. Most of these species like our water, they actually are available in the frozen state. So we always think that scientists always think that this lunar South Pole may be the reservoir for such kind of water. So that is one of the reasons. Even actually Americans also, there is one recent experiment called L-Cross. They drop intentionally, they crash one like a bomb. Okay, they crash like impact, and then they ejected some of this ice, this one, and they analyze in situ. So this is one reason, and moreover, another part is, and it also believed that helium-3 deposits also there in the lunar South Pole, sir. That is also one of the reasons that these are the three reasons why we are interested in the South Pole.
Okay, so before I start taking questions from the house, please limit your questions to few words, and it would be good that if questions could be restricted. So I think you people can prepare for raise of hands and selecting people. So I'll just have a message from you, sir, for all these students. So what should they do in school, in college, and what future do they have in space technology?
Sir, actually, because of the slide, there is issue. I have included one slide called Yubika. Okay, you may be knowing ISRO Young Scientist Program. I wanted to put that slide basically because of the issues. I could not project that one. So for students who are studying class 6, 7, and 8, because there is one program called Yubika, ISRO Young Scientist Program. So those who have passed class 8, they have a good opportunity to undergo 2 weeks program, Young Scientist Program in ISRO. You will be actually taken for 2 weeks programs in 7 centers of ISRO. So it will be very engaging, very actually enriching program for all of you. So that slide you please visit, or otherwise I'll be leaving the slides here in Space India and a Balvardi School. You can take from there. It is very interesting program. You please do come. And all this is open for all. There is from all 28 states, 7 union territories is open for everyone. So please do apply. And moreover, I'm telling you, there is special advantages. Those who are good in sports as well as NCC, NSS, all those considerations are there. So if you are multi-talented, you are more actual opportunities more. Please do come to ISRO and get your training done. And those who are after class 12, basically, we have one institute called IIST. This is IIST, means University of Space Science and Technologies. This is Trivandrum. So basically, if you are very good in this one, you write for G entrance. Through G only selection is done, and your BE, BTech, everything is free of cost. Your parents will not spend even a single penny for you. Everything will be taken care by ISRO. So everything is free, and you will be absorbed directly to ISRO. And if you are not happy, if you are good, again you can leave ISRO and work for some other bigger goals in life after 5 years of service. Okay, these are the two messages I want to send you for this mix-up forum.
Yeah. So thank you. We will now have questions from the house. You just need to take the mic, introduce yourself, which institution do you belong, and we can have the questions. We will restrict it to 15 questions, and I would like to invite the house at around 12:30. So we can have the first question from the gentleman there. Yes, you.
Good afternoon, sir. I'm Rohan Nagpal from Jaspalkar Public School, and I want to know that will human beings ever be able to build a colony on Moon? And if yes, when will that be possible?
Thank you. Thank you. See, I must tell you the word colony is not the right word, because always people tell about colonization. So the colonization is not a good word. We should avoid that one. Okay, that is one part. So rather we should make it different. Like our suppose we see like nowadays people are telling no that gender. Always people when we say the chairman, always our this one another gender they are telling. So it is gender different. It's like a chairperson we always telling. So like that only now this colony when we say colony like is exploitation. Okay, so this is. In law, it is not allowed. I must tell you, Rohan, that see, Moon by nature is not habitable. So if you want to make it habitable, you need water, you need oxygen. So by default, these are not available. So if you want to make it habitable, it will be only localized situation. So what is happening is, in order to construct something, two things are there. Either you transport from here everything, you inflate it there, live there like a localized one, like our ICU chamber, you make all your oxygen available, everything is available. Okay, that is one part. Another part is use the resources available. There is concept is called in situ resource utilization in scientific terms. In situ resource utilization means that whatever the moon soil is available, moon soil regolith, 45% is oxygen. Okay, it contains most oxides only. So these from this oxygen, you can oxides, you can extract oxygen. Okay, so this is the one part. So in situ resource utilization, and moreover, you can use the space bricks. You can build the bricks using some bacteria, live other microorganisms. These are the concepts. But however, such kind of habitable concept, it will be only localized for the whole actually celestial body moon is not possible. It will take time. Only like localized habitation, it is possible. Did I answer your question?
Yes, sir.
Yeah, thank you.
So can I have this kid? Yeah, young Jack. Yeah.
Good afternoon, sir.
I'll finish this house first, then we'll come to yours. So you can rest. We'll finish. We'll take 7 questions from there, and we'll take 7 from here. Yeah.
Good afternoon, sir. I am Rona Bhatia from Ravi International School, and my question is that how shape instrument can find about other exohabitable planets from like moon? How can it tell us about other habitable planets?
Thank you, Bhatia. So, Beta, I told you that see the shape instrument. Our nearest star is Proxima Centauri, which is 4.2 light years, because light takes 4 years to reach and to come from there. Okay. So this shape instrument, if I think all these are actually frames of reference. Other aliens think that ours is exoplanet. We think that theirs is exoplanet. If you are in the bus, when you look at outside, standing tree looks like it is moving, correct? But tree is standing only, basically your car is moving, your vehicle is moving. So it is called a frame of reference. So what is happening is, instead of I looking the exoplanets, because these are very far, only I can see the signature from telescope, from the light, because my nearest exoplanet is our own planet. So if I see from a distant point, then see the signature, then I will compare whether such signatures are available from other planets which I have observed. That way, set will be helpful to find exoplanets. Clear answer, Bhatia? Thank you.
So hand in the back, the young lady. Yeah.
Good morning. I'm Rekha from Amateur International School, Center 43, and I just wanted to ask, how does ISRO manage the balance between innovation and risk management in its ambitious space endeavors?
Please repeat answer.
So yeah, she wants to ask, how do you manage the balance between the innovation and the mismanagement of, if you would say the last word?
How do you manage innovation and risk management in your in the space endeavors?
Okay. In the space endeavors?
Yes.
Okay. So she means to say, why when you are a kind of a child and trying to do a lot of things, you sort of stray away from your goals sometimes. So how do you manage so much innovation going on and still are on the right track? Probably this is the question, am I right? Yeah.
Okay. Thank you. I forgot Reha or something. Okay. Yeah. Fine, no problem. So it is a good question. So we will try to answer is actually managerial questions, because you see, management is very important. How rich you are, if you don't know how to manage your money, basically we all end up in bankrupt. Correct? This is very important. Like there are so many billionaires, we see their downfall in their career, but basically they are rich people only. So like that only, so such organizations like ISRO, we have an organizational mandate. We have a fix what mission to be taken up, what should be prioritized, okay, and what risks we have to take. And everything we are not doing, we are doing with approval of the government of India. So we have the different review mechanisms, we have different actually approval mechanisms, we have the central level, we have the ministry level, okay, we have the PM level. So all the risks, when such we pass through such kind of review and strict regulations, these risks are minimized. Okay, that is one part. Even what is happening is, nevertheless, there will be some minor actually technological glitches will be there. Those are taken care by the scientists by post-failure analysis. Then next time we correct it. Okay, so this is how we streamline our mandate. We prioritize our mandate depending upon national goal as well as national priorities set by government of India.
Thank you. So hand there, yeah.
Good afternoon, sir. My name is Janet and I'm from Marketing High School. We have found several rare minerals on the surface of Moon. So, sir, what can we do to bring those rare minerals to Earth?
Basically, such kind of rare minerals, even you see the asteroids, we think that they also have a very good deposits of such kind of minerals and all those things. So we call space mining. Okay, this term is very popular one. You also read space mining says that how to, you see, asteroids and all those things, it does not belong to anyone. Moon does not belong to us. Moon does not belong to any country. Moon is for everyone. Okay. So like the asteroid also, it does not belong to everyone. And I remember that there is one moon mining mission from Japan. That is some Haishabu kind of things. Okay, I remember correctly. You please correct me if I am wrong. So this experiment also they went, they touched it, then it came back. Okay, and such kind of and there is no international law in that you cannot mine. I told you that there is a country called Luxembourg in Russia. Europe. So they are actively involved in such kind of space mining and asteroid mining. So only possibility is we have to go there, we have to mine, then after that we have to bring. This is the only possibility with space mining. Okay.
So last question from this house. I'm sorry about the hand set back. You can send a mail to Space India or to Sir directly, and we will get them answer. So, this young chap, yes, please.
So, what are God particles?
Actually, both particles, these are in elementary particles, these are called baryonic particles. Okay. So what is happening is, okay, I can tell you, you know about these atom, electrons, protons, neutrons, correct? So what is happening is, elementary particle means the particle which you cannot again break it down. Earlier, we think that atom was not breakable. When John Dalton actually he made the hypothesis, correct? Then what happened is we understand that in the nucleus, protons and neutrons are there and electrons are revolving. But later on, some scientists called the Murray-Gell-Mann, they started doing a lot of experiments, then coming to the conclusion that protons and neutrons are no longer elementary particles. Still, electron is elementary particle because electron you cannot break it down. Okay. So what is happening is inside proton there are another three particles are there. This is called quarks, and quarks are having in six levels. One is proton is made of two up quarks and one down quark, and the neutron is having made of two down quarks and one up quark. Okay. Again, these quarks, how they are together? They are called gluons. Okay. All again these gluons again these are again binding with baryonic particles. These particles which is coming down and down, these are called gold particles. Okay. So this is generally, I must tell you that recently it was actually experimentally, they claim that they have found it, but these experiments, such kind of experiments are very costly. It's called the Large Hadron Collider, which is happening only in Geneva in Switzerland. Okay. So so when you grow up, please study and find more gold particles. Thank you.
Yeah. So basically, we are reaching almost to the particle that is generating matter. So we are almost seeing energy generating matter. So they are called God particles. We are bringing atom to the next level, and we will switch to this house. And maybe if somebody is left from this house, you can write your questions. So we'll switch to this house. So we can start from the back. The gentleman in line.
Good afternoon, sir. I am Avi Srivastav from JP Public School, Noida. Sir, it's like what happened in the opportunity overseas, it outlived its expected lifetime by almost double. So is the same possible for the rover and the lander of Chandrayaan 3? And if it is, will the mission time be extended for it?
Yeah. Beta, I was telling that actually mission design is only 14 days. 14 days means only 14 sunlit days. Because night time is so cold that you don't have blanket. Because if you go to this Mount Everest, it will be very cold, no? If you don't have the blanket, because we cannot bear that cold. Okay. So like that only, we do not have the proper blanket to make our lander and rover warm. So therefore, we have to remain there only for the 14 days. But however, I also told you that there are some electronic mechanisms which we have built in these systems. So if it works, we call it sleep and wake up circuit. By default, we'll be able to extend another 14 days, another 14 days, another 14 days. Like that only, we'll be able to survive till the circuit works. Okay, did I answer your question?
To the back again, 3 rows from him in front. Yeah. You can give it to the lady at the back. Yeah.
Good afternoon, sir. My name is Ritul in St. Thomas School, Dwarka. I would like to ask that why are the discoveries of moon so important for us?
Yeah. Actually, see, I told you that moon moon was formed, see, when we go to the moon, we should understand moon has preserved the history of 4.5 billion years. Okay, the craters which is available today was formed almost 4.5 billion years before. And moreover, the craters are very interesting in the sense that the crater walls, some craters are so deep, and the crater walls, if you see there is one actually Katori, you know na Katori. Katori का actually जो मतलब wall है, उसमें क्या है, वो इसमें sunlight नहीं है, ठीक है? It's like a bubble only. So like here, whatever, when there is no sunlight, there must be some species. As well as actually whenever there is a crater form, because there is a foreign species also involved. So foreign species involved means we will know what is the signature of the foreign species as well as the native species. Correct? Because the moon native species as well as the foreign species we can find out. And moreover, crater walls is never explored till now. It is a very well reserved of these resources. We never know. Therefore, we want to know about its formations, about whether I told you that whether moon was formed by 4 theories. So one of them is valid. Otherwise, some more theory may be there. All these discoveries mission to moon, we will have to understand moon better. Okay, and moreover, to survive later on, because moon, to go to Mars, moon actually basically we want to use like a base to go to other planetary systems. Okay.
Okay, so can we come to the mid of the house and start with the leading between? Yeah, you. No, yeah, yes, you. The one looking back. Yeah, please.
Good afternoon, sir. I'm Anshika Palakwal from JBM Global School. And my question is, how are astronomers able to prevent the spacecraft from crashing into space debris and asteroids?
Thank you. So we are coming to the space debris. Very nice. Okay. So space debris. See, space debris, there are two types of debris. One is man-made debris, another is natural debris. Space debris, mostly we are actually man-made debris. Earlier, when once the first satellite was Sputnik, correct? When it was launched, only one satellite. Today, actually, thousands of AC, starting our boss Elon Musk is launching thousands of satellites. So all become in the Leo orbit and all other orbits. So what happens is, when their life is over, they all become space debris. And when two satellites collide each other and fragmentations, you might have heard of iridium collisions, or the iridium satellite collides. So again, different fragments have come. And I have you about the anti-satellite test. India also has done a test. Anti-satellite test means you have to shoot down a satellite from rocket, from here, missile. So that also creates a lot of debris. So space debris mitigation, I'll tell you. One part is another part is micrometeorites, which is coming in a very hyper velocity, it is coming and hitting. So even you may be thinking that International Space Station is continuously hit by micrometeorites. Sometimes there is a puncture. So they have a shielding mechanism called Whipple shielding mechanism. Scientifically, it's called Whipple shielding mechanisms. So which got from micrometeorite impacts. Another part is by mission design itself, we know where the debris are there because the different telescopes. Okay, different telescopes. We have the International Debris Coordination Committee, which is working all together by these interagencies, NASA, ISA, and ISRO. So we know that where the debris are there, where more than 10 centimeter, we can identify. We have a catalog. So we will design a mission such that our orbit will be there, so that we will not collide to the debris. Okay.
Okay, so loitering, we understand, it's a problem on Earth and now it's a problem in space also. So if you have a kind of solution for this, would be a wonderful company to start, and everybody is looking forward to young minds to come up with solutions to these problems. So can we have this gentleman? The corner guy.
Yeah, just 1 minute. Sir, before that one, when Sir was telling, just 1 minute, just hold a line. About this self-sustenance of this space debris, there are two concepts are coming. Okay, one is whatever is available, we have to clean. So Japan has started using the cleaning agency. Okay, using the space net. There is some teacher mechanisms are there. They are cleaning. Another part is we should not create more debris, further debris. So in that case, we are actually we are taking a new initiative called the self-eating rockets. Self-eating rocket means रॉकेट वो उड़ने के बाद वहां पे नहीं रहेगा, अपना आप वो गायब हो जाएगा, ठीक है. Another is called self destroying satellite, self vanishing satellite. Have you heard about this Carrefour जो हमारे कमरा में रखने के बाद 4 दिन के बाद वो गायब हो गया ना, करेक्ट. So that means transformation of the phase from solid to liquid, solid to gas without transforming to liquid state. So these are called actually in scientific technology. So just 1 minute, I'll take. This is called different mechanisms are there, but what is happening is self-destroying satellites. I mean, self-eating. This one, there are certain materials are there. You know, biodegradable materials. Biodegradable plastics are coming with degrade. Biodegradable material is slowly degrades because it is a polymer. But such kind of materials we call as a self-vanishing satellite. The self-vanishing material means it has only one master bond. So this master bond, once it breaks, all other bonds will be broken automatically. So that bond breaking is called the steric strength. So once we hit the ceiling temperature, we call it ceiling temperature. This master bond will be broken by steric strength, and all the satellite and other materials will be vanished in space. So this way we will have a clean. This is the actual future technology coming up.
Good afternoon, sir. I am Daiki from Prudence School, Dwarka Sector 16B. We all know that ISRO has progressed over the last 54 years. So, what do you think is the future of ISRO? Like, will it collaborate more, or what discoveries do you expect? Are you hopeful, or?
You know, actually, we are expanding our missions. We are expanding our horizon. We are actually in immediate future. I must tell you that okay, we are planning to build our own international own Indian space station. That is one of the goal. And another is we want to extend our Satyan Gaganyaan program, because we also want to do this continuous series of astronaut missions to the and another part is we are also trying to do the space tourism. Space tourism in the sense that we will go to space, stay there for some time on commercial basis, we'll pay some money and come. Okay, these are some of the activities apart from our other exploratory missions. Okay.
Okay, so we will take the last question from the house, and this boy, yes.
Good afternoon, everyone. Good afternoon, sir. My name is Ansh Malik, and I'm from DAU Central Public School. I would like to raise a question that what is the significant impact of Chandrayaan 3, and what skills and talents are important to join ISRO?
Chandrayaan 3, because Chandrayaan 3 is important in the sense that we will be the 4th country, correct, sir? We will be the 4th country to land on the moon. So, in spacefaring nations, there is always a race, either today or tomorrow or yesterday. There is always a race. Even your life is a race, because everybody knows the information. Who can deliver, think that he is the winner. So, India is also on the race among spacefaring nations. So, our Chandrayaan 3 is very significant in demonstrating our technology excellence to the spacefaring nations, that you see, we are also able to land indigenously with our own technology without support from any other country. Okay, that we will say that it is really pride for us. And moreover, this will be actually like a benchmark for venturing to the subsequent missions, because subsequent missions, even if we go for the sample return missions, it has to go a lander, and lander has to again come back. So this is a very significant milestone for us, that which will demonstrate landing as well as the roving on the surface. Thank you.
Thank you everyone. I think it was a long session for him, and I can see the excitement on your faces. I don't think this session will ever end, and there will always be questions. So my apologies for not taking any more questions, and you can send a mail to us or directly to him. And I would just like to add that this was a wonderful session we had, sir, and we look forward to having you more with the kids. And thank you so much for giving us time today and being so patient in explaining so much science and so much possibilities to these kids. My sincere thanks on behalf of everyone.
It is great honor for me.
Thank you so much.
It is great honor for me to interact with you. I hope I am not disappointed you. Okay. So yeah, we look forward to have more interactions in the future as well. Yeah, thank you.
Thank you for the dignitaries and also to the audience. I know most of your questions